Hello guys, very good evening, very good morning everyone. Welcome to the session and welcome to the India's most comprehensive learning platform, the Byjus Exam Prep. So yes guys, I know you have been waiting since quite some time. So the internet was down at my place and yeah, so I had complaints since yesterday evening. The Airtel people came up in the morning. The work was going on continuously since morning, but yes, finally the patience paid off. Right, so I also didn't want to cancel the session because we had planned this DFT session specially for you. So we are starting around 15-17 minutes late, but I think the Joe should be as high as 11 AM, right guys? So very happy Dussehra to everyone. It's a festive day, it's a festive season, and as a GATE aspirant, as a true GATE aspirant, actually festive always brings us happiness. Okay, what can be your best happiness for the festive day? That you have utilized the day, that you have studied hard for the day, that you have learned something for the day, and if you do that successfully, then it becomes a happy festive day, at least for a true GATE aspirant with 3.5 months spare to appear in the GATE examination, right? So I think, yeah, let's utilize this day to conquer one of the important topic, DFT, because that is one of the topic where you can expect some good and tricky questions, and every year questions are expected from this topic. You can see a question in the GATE 20, GATE 21 and etc. in the previous years as well. So we'll be covering up those questions. We'll be covering up properties and tricks, everything in this session. And let us revise and complete the DFT in this particular marathon sessions, right? Yes guys, once again, happy Dussehra, happy Vijayadashmi. So it's been a little bit late. Let me also share this session once. Let me share this session once on the Telegram as well. You also can now update your friends that finally the session is live. So I was really behind the Airtel guys ki anyhow we need the internet connected by morning only, and successfully they have done it also. Thoda sa late hua, but I think that's okay. Some plus ups and downs will keep on happening, right guys? Okay, chalo, let's begin up. See, Kanugula, it depends on the mood of the examiner, so we can't take any one of them lightly. Usually you will see more questions of the transforms. If I take up all the transforms, now transforms means what? Transforms could be the continuous time Fourier transform, DTFT, Z transform, Laplace transform, DFT. So if you want to cover up the transform area, it's huge. So of course more questions can be expected, but as you have seen, sometimes they are asking the very good questions from the continuous time Fourier series. Okay, if you have doubt in the discrete Fourier series, although we are going to study the DFT today, but let me know if you have any confusion in the DFS, discrete Fourier series. If somebody is good in DFT, if somebody is good in DFT, discrete Fourier series is just like this. Just kaisa? If you are comfortable in DFT, what is DFS for you? Just like this. Mazak nahi kar raha, it is just like this. So if you have any doubts or any more queries regarding the discrete Fourier series, that also you let me know in the comment box. Maybe at the end of the session, I will give you a help regarding to the DFS also. Okay, and very easily, maybe it will take me 2 minutes. Okay, I'll tell you how easy it is if you go for DFT, and DFT is anyways very important that you can't skip up. Okay. So yes guys, anticipating more students for this special session of DFT, come on, keep on sharing and let's start the session. In case if you are new to my session, this is a brief intro about me. This is your mentor and educator Rakesh. Secured All India rank 9th in the GATE examination and having completed my masters from Indian Institute of Science, Bangalore. I've spent more than 11 years, trained more than 50,000 students in this industry for ESE GATE and PSU's examination. My area of expertise in technical is control, signal and system is what we are studying today, digital electronics and EMFT, and in the general area I also take up the maths and aptitude, right? Morning everyone, happy Dussehra once again. So let me keep you updated that whatever we study here, okay, if you want, what I want from you, it is a non-stop marathon. I want only your patience, only your concentration. Okay, take out a notebook, a pen to solve up the questions. Okay, to note down the important tricks. Rest all the detailed properties, formula, everything. Do you have to note down? Absolutely not. I'll give you the PDF. I'll share you the PDF. of this session. I'll share you the PDF of the session. Where I'll share you the PDF? I'll be sharing you the PDF in the Telegram group. Okay, so you can join my Telegram group. Okay, GATE/EAC by Rakesh Talreja, and I'll share you the PDF today evening for the entire DFT, that whatever we are discussing. You just keep on having a notebook for solving up the questions and noting down some important tricks. Rest all whatever we discuss is there in the PDF. Okay, also guys, one more important update for you guys, that tomorrow is Saturday. So when the tomorrow ends, Saturday night, when the midnight starts, dikh rahe hain tare chand, it's a midnight dose for you. Okay, so all general aptitude IIT Kharagpur questions. Okay, so what are we are going to discuss? We are going to discuss their solutions. We are going to talk about the level, and we are going to talk about the, based on to the IIT Kharagpur, we are going to talk about the expected questions of 2022. What can be the expected questions of general aptitude for 2022? What was the level of IIT Kharagpur aptitude questions, and what are their solutions? What areas they have tried to cover? Okay, with the detailed solution. So it's a midnight dose with me tomorrow, Saturday night, ending at 12 AM. That means officially Sunday will start. Okay. So that's also a non-stop marathon in the midnight style. So you can join me live, same channel, same place, tomorrow 12 AM, right? So it should be officially Saturday night 12 AM, right? 12 AM रात के एग्जैक्ट जैसे ही 12 बजेंगे, जैसे ही संडे का दिन लग जाएगा, हम लाइव हो जाएंगे. ओके, विद दिस सेशन, राइट? चलो, all cool. Moving ahead, right? So guys, discrete Fourier transform. Now let's come back to our topic. Let's start it up. Already it was a little bit of delayed now. So let's start it up quickly now. The discrete Fourier transform. Basically, if you are comfortable with DTFT, and I believe DTFT is actually simple. If you are comfortable with DTFT, many of the properties you will directly be able to recall from DTFT. Nothing new from discrete Fourier transform. So guys, for a moment, if I want you to recall what was DTFT, for a moment, let us recall DTFT. Okay, what is the DTFT? X of omega, right? X of omega is given by summation of xn e raised to the power minus j omega n for all the values of n, minus infinity to infinity xn e power minus j omega n. That is what is known as the DTFT. Okay, then what is the IDTFT formula? Okay, what is the value of, how do you derive xn from here? Xn is given by 1 over 2 pi integral for 2 pi x omega e raised to the power j omega n d omega, integral over 2 pi. This is what is the IDTFT formula, right? No, Vishnu, this is not GATE AMers. GATE AMers officially class will start from tomorrow. Okay, the GATE AMers. There is a separate DFT non-stop marathon. Okay, so guys, when you talk about DTFT, can you comment? When we talk about DTFT, the frequency omega, this frequency omega, whether this is a continuous variable or a discrete variable, we are talking about discrete time Fourier transform, Fourier transform of discrete time signals. We know the time is discrete. We are talking about a discrete time signal and the Fourier transform of discrete time signal. But when we talk about the Fourier transform of discrete time signal, that is what is DTFT. In that DTFT, what is the omega equal to? What is the omega? Whether it is discrete or whether it is continuous. That omega is discrete or continuous. Whether that omega is the discrete or continuous. Comments on that. Whether that omega is the discrete or continuous. Yes. So yeah, you must be aware of that. This omega is a continuous variable. Omega is a continuous variable. So maybe, for 5 minutes I'll give you the briefing of the DFT and then we start with the properties and questions. More focused in the session will be questions and properties. Omega is a continuous session. Okay, continuous over a period of 2 pi. Continuous over a period of 2 pi. There is something that you might be knowing about DTFT. That DTFT is always periodic. DTFT is always periodic with a period of 2 pi. x of omega plus 2 pi is equal to x of omega. X of omega plus 2 pi is equal to x of omega. DTFT is always periodic, having a period of 2 pi. That means DTFT is the omega is a continuous variable spread over a period of 2 pi. Now for digital processing, okay, for digital processing, of course, okay, agar ye continuous hai, to continuous means how many values of omega will be there over the period of 2 pi. If you have any real continuous variable, okay, from minus pi to pi, aisa maan lijiye, from minus pi to pi, if you have any real variable, how many samples, how many values it can take? How many real values can lie from minus pi to pi? Sir, it will be infinity. There will be infinite frequencies. Okay. So these days, Sangeet, it is getting important, more important towards the discrete area. Okay. So that is why electrical also should focus it. Okay. So how many real values can lie from minus pi to pi? Of course, it can be infinite number of frequencies. And for digital processing, for computer-based processing of any Fourier transform also, in a computer we can only store, a digital machine can only store finite number of samples. It cannot store infinite number of samples. Okay. So since I am telling you omega is continuous, can we discretize it? Okay. Can we convert into a discrete frequency? Right. How to discretize omega? How to discretize it for digital processing? Digital processing के लिए इसको मैं कैसे discretize करूंगा? So I'll be just giving you a very simple idea, and from the DTFT we will jump to DFT in a minute. Okay. Basically, let's define the discrete frequency. Let us define the discrete frequency, which I am going to call it as omega k. My idea is, let's keep a simple idea. We are talking about the Fourier transform of a discrete time signal, and then we are talking about digital processing. Now, if you want to store a signal, by Fourier transform kiska nikaloge? You will calculate the Fourier transform of a signal, of a discrete time signal. Right. So first, for the digital computation, first you have to store the input signal, the xn, into the digital machine. Right. And any digital machine can only store finite number of values, not infinite. Okay. So first condition for the digital processing is that this xn also should be a finite length signal. Dhyan dena. This xn also should be a finite length signal. It should not be an infinite sample signal. Right now we take xn is minus infinity to infinity in general, but for any signal to be stored in a digital machine, it should be having finite number of samples. It should be having finite number of samples. ठीक है? So हम क्या करेंगे? First of all, let us consider xn as a finite length signal. Now all of these things are very important for the conceptual understanding, so I'm giving the briefing of that. That's what. Let xn be a finite length signal of let's suppose length equal to n. Suppose length equal to n. That means I want a signal xn, okay, I want a signal xn which is 0, which will be 0 for n is greater than n minus 1, and it will be non-zero for 0 less than equal to n less than equal to n minus 1. Because I start the counting from 0, so 0 to n minus 1, total n samples it will have. So I want to consider a signal which is itself finite in length, so that it can be stored in a machine. Now, how to define the discrete frequency? Idea is the omega is a continuous frequency. Omega is a continuous variable over a period of 2 pi. Acha. I want to discretize it. I want to consider limited set of frequency. What is the idea to define that limited set of frequency? How many samples are there in the time domain signal xn? How many samples? N samples. The idea is, if a signal has n samples, let us say the Fourier transform will also have n frequencies, n discrete frequency. So let's divide the 2 pi by n and write down the factor k, where k can be 0, 1, 2, etc., n minus 1, and I am going to call it as the variable known as the discrete frequency. I am going to call it as a variable known as the discrete frequency. How it is discretized and how n samples, just put down the values. Okay, that means this value will become 0 if k equal to 0. Then you will have 2 pi by n. Then into 2 kiya, you will have 4 pi by n, then you will have 6 pi by n. So you have these limited discrete frequencies 0, 2 pi by n, 4 pi by n, etc., 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 up to the last frequency, that is 2 pi by n into n minus 1. These are known as n discrete frequencies. These are known as the n discrete frequencies. So finally, what was the x of omega formula? Summation of xn e raised to the power minus j omega n for all values of n, but this was the DTFT formula, okay, in which the omega was continuous, and now I give you the DFT formula by the idea of this discretization. So what should be my DFT formula? What should be my DFT formula? X of omega k. Omega will be replaced by discrete frequency, x of omega k equal to summation of xn e raised to the power minus j omega kn. Acha ji. Now xn is only defined from 0 to n minus 1. Again, you can have a look into this. Xn is only defined for 0 to n minus 1, otherwise it is 0. So limits also will also be from 0 to n minus 1. So summation 0 to n minus 1 xn e power minus j omega kn. Sir, what is the value of omega k? Put down the omega k as 2 pi by n into k. What you are going to see is the DFT formula जो आपने देखा होगा, right? That is what is the DFT formula going to come up in front of you. So we have summation n equal to 0 say n minus 1 x of n e raised to the power minus j 2 pi by n k and then multiplied by n. That is what is the DFT formula. That is what is nothing but your DFT formula, right? Now it is a function of discrete frequency, but the discrete frequency is a function of k, right? Discrete frequency is a function of k. So ultimately I can say that the DFT is a function of k. So we commonly write it as xk. We commonly write it as the xk. Sir, here लीजिए. This is what is the DFT final formula. So this is how, very briefly I've spoken. There can be many more details, but right now, okay. See the idea, that is the idea I've told Kanugula. I want is a continuous variable spread over 2 pi. So let us divide the 2 pi, okay, into n samples. Why n samples? The idea was that the signal xn contains n sample. Let us say that Fourier transform also contains the n sample. Acha, why exactly n? That will also get little bit clear when we go towards the processing of the signal. Okay, so whatever basics was required, मैंने उस तरीके से brief किया है. So divide 2 pi by n so that we get, the frequencies equally spaced by a period of 2 pi by n. Okay. Right, so this is what is the DFT formula जो आपने देखा होगा. I know this is what you have seen. Yes, Narendra. Yes, Naren Prasad. It is discrete and periodic. We are going to come to all of those points to have a look into this. That is what I've already briefed to you. Let xn be what? Let xn be a finite length sequence. So DFT will be defined for a finite length signal. Please mind, DFT will be defined for a finite length signal. Okay, that is having the length n. Okay, and xn equal to 0 outside this interval. That is what I've already spoken to you. Now n point DFT, we call it as n point DFT because the DFT, the value of k, let me write down here once again. What is the value of k? 0 से n minus 1. What is the value of k? It is 0 to n minus 1. ये देखा था ना? What is the k? 0 to n minus 1. So how many points will be there in the DFT? N points will be there. So we call it as the n point DFT of a n sample signal. N point DFT of a n sample signal. Okay, and the IDFT final formula are once again written in front of you. X of k, the DFT formula, is summation 0 to n minus 1 xn e power minus j 2 pi by n nk. Whenever you forget this formula, you can call it as e power minus j omega n. Which omega? Discrete omega. So always remember the discrete omega formula. ये important है आपके लिए. Even many of the properties you can connect by this. Many of the properties you can connect by this. That is why this discrete omega is very helpful for you to remember the properties also. So if you remember this discrete omega, I will make you say that actually no additional properties you will remember for DFT. अगर आपने DTFT या Z transforms etc. study किया हुआ है, will make it all related to each other. Okay. So, and the IDFT formula, inverse discrete Fourier transform formula, 1 upon n summation xk e power plus j 2 pi by n nk for n equal to 0 to n minus 1. This is known as the n point DFT and this is known as the n point signal, yeah, n sample signal, one and the same thing, right? One and the same thing. Now, In this, let's try to write it in a proper way. What is this factor e power minus j 2 pi by n? We have the factor e power minus j 2 pi by n, which is known as the nth root of unity. Okay, that is what is going to represent the DFT matrix, also known as the Twiddle factors. Okay, now although if you go with my experience and if you look into the gate problem, even the simple problem or the good level problem, maybe you don't have to go for matrix form and all. Very simply, I'll give you 2-3 set of properties जिससे आप सारे questions को बहुत easily handle कर पाओगे. Okay, so let's say Wn is e power minus j 2 pi by n, which is actually the nth root of unity, the complex nth roots of unity. And in the form of Wn, the xk will become summation xn Wn power kn, and inverse DTFT will become like this. IDFT will become like this. Achha. Sir, what is the value of this W? For example, how to calculate the value of this W? Suppose what should be W2? Okay, what should be W2? E raised to the power minus j 2 pi by n, n barabar 2. So that is basically e power minus j pi. What should be e power minus j pi? What should be e power minus j pi? Cos of pi minus j sin pi. Sin pi is 0, cos pi is minus 1, so it is just equal to minus 1, right? What should be the value of W4? Now, ye important hai. Why? Majority of the questions which comes on direct calculation in exam like GATE can be on 4-point signal. For 4-point signal, if a signal is of 4 points, what will you calculate? W4. So what is the W4? E raised to the power minus j 2 pi by n, 2 pi by 4. So that is basically e power minus j pi by 2, which should be cos of pi by 2 minus j sin pi by 2. Now everybody knows cos pi by 2 is 0, sin pi by 2 is 1, so that the value of W4 is simply minus j. The value of the W4 is equal to the minus j, everybody. The value of the W4 is minus j. Similarly, we can calculate W8. Any value we can calculate wherever we want. Suppose e power minus j 2 pi by 8 will become e power minus j pi by 4. So eventually cos pi by 4 minus j sin pi by 4. Cos pi by 4, sin pi by 4 are both equal to 1 by root 2. So it will be 1 minus j whole divided by root 2. So like this we can calculate all the value of W. Although I suggest you always remember W4. I suggest you always remember the value for the W4. Acha ji, theek hai. Then by simple mathematics it can be proved that, okay, the proof is also written here. Let us not go into simple proofs. Whatever is very simple proof, you will automatically, you can refer into it later on. So it can be easily proved that x of k plus n equal to xk and small x n plus n is equal to x of n, representing that both the DFT and IDFT are periodic with the period n. Both the DFT and IDFT, all important points we are writing, okay? Both the DFT and IDFT will be periodic having the period of n, and that is why it is sufficient to compute the results only for one period 0 to n minus 1. Rest it will be repeated. Sir, what is the 4-point DFT of 2, minus 1, 3 and 1? Let's start with a question, okay, basic question. Then we'll take property based question. Then we will take the competitive level questions, indirect, some good tricky questions, recent year questions, सब कुछ cover करेंगे हम. Okay, sir. What is the 4-point DFT of this 4-point signal 2, minus 1, 3 and 1? Of course, if not specified, the first sample at origin. The first sample is at origin. So we have a 4-point signal x of n, which is equal to 2, minus 1 and 3 and 1. 2, minus 1, 3 and 1. So what should be the 4-point DFT of this? Interpolation वगैरह की बात भी करेंगे. Okay, there are some good questions in GATE regarding to the interpolation of the signals and the DFT of their interpolation. 4-point DFT means x of k, official formula is summation n equal to 0 to n minus 1. That means 0 से 3. x of n, W4. देखो Wn आता है ना, in general what do you have? You have Wn power kn. So W4 will come because I am talking about the 4-point DFT. W4 raised to the power k4. W4 raised to the power kn, right? That is what is the DFT formula for this particular question. Now what is the value of W4? ये भी रख देते हैं हम. So xk is equal to summation of xn. W4 का वैल्यू कितना आया? Minus j. W4 value everybody knows. W4 value is the minus j. W4 value is the minus j. E power minus j 2 pi by 4. Okay. W4 value is minus j. So minus j is raised to the power kn for what values of k? 0, 1, 2, 3. That is what is the problem statement now. Now when I start writing down, देखो once again xk, let me rewrite this here. Xk is summation n equal to 0 से 3 x of n into minus j raised to the power kn for k equal to 0, 1, 2, 3. अच्छा. Let's start with k equal to 0. What is x0? This will actually be a property. Anytime guys k equal to 0, have a look at this here. Whenever you put k equal to 0, whatever may be the w value, w power 0, kitna hoga? W power 0 is 1 and you only have summation of xn. You only have summation of xn. Now these are some points to get hold of the MCQ question. So summation 0 se 3 xn. Summation 0 से 3 xn, that means x0 plus x1 plus x2 plus x3. So I don't see, I'm not only focusing on one question. We are deriving the general points here. Nana, discrete hai, it is not area, it is summation of the signal, Ashutosh. Okay, x0 plus x1 plus x2 plus x3. This you have to remember for always. This is always true. Okay. तो x0 is always summation of xn. So what is the value of x0 here? यहाँ चलो पहले let me take next idea. K equal to n by 2. K equal to n by 2. I will officially list this with the properties. Properties के साथ officially बताऊंगा. What is the value of k equal to n by 2? Center point हो जाएगा यहाँ पे 4 by 2, that is 2. Okay. So what is the value of x2? Right. What is the value of x2? देखो, it will become summation n equal to 0 से 0 to 3 x of n, right? X of n minus j raised to the power 2n. Minus j raised to the power 2n. Okay, calculations हम बाद में करेंगे. Minus j power 2n. Now what is the minus j का whole square? Minus square is plus 1, but what is the j square? J square is known as minus 1. So ये हो गया summation n equal to 0 से 3 x of n minus 1 की power n minus j square is minus 1. That's it. So minus 1 raised to the power n. Now this means n equal to 0 रखा तो you have x0 minus 1 की power 0 is 1. But whenever odd samples are coming, n equal to 1 minus 1 की power 1 is minus 1. तो x0 minus x1. Minus 1 का square will be again positive. Minus 1 का cube will be negative. तो minus of x3. What is the idea? Let me generalize this. इसको generalize करके रखते हैं guys. So in general, always remember these are important. Maybe your MCQ question can only be solved by these 2 points. Okay, if it is a simple question. Tricky question पे भी आएंगे. We will come to tricky also. Don't worry anything here. So in general, what is the value of x0? It is summation of xn from n equal to 0 to n minus 1. That is summation of all the samples x0 plus x1 plus x2. जितने भी samples हो, right? But what is the next? X of n by 2, central ordinate. We call it as the starting ordinate and central ordinate of the DFT. What is x of n by 2? It is always equal to summation 0 से n minus 1 x of n into minus 1 की power n, and that is given by x0. Always it will be alternate in sign. Minus x1 plus x2 minus x3 plus x4 minus plus alternate. It will keep on rolling ahead. ठीक है? This is what is the general thing you should remember. ठीक है? चलो, so let's jump back to the question. Let us jump back to the question. So what is the question given to me? What was the question? 2 minus 1, 3 and 1. 2 minus 1, 3 and 1. Okay. What is the DFT? So what is the x of 0? What is the x of 0? 2 plus -1 plus 3 plus 1. This is very simple na? This is very simple. So कितना हो गया? -1 cancel, 2 plus 3 is 5. Okay. Then let's go for the central ordinate. X of n by 2, that is x of 2. पहले x of 2 निकाल लिया. What is x of 2? Alternate sign. 2 minus of -1 plus of 3 minus of 1. Put the alternate sign. Alternate sign for the central ordinate. Okay, 2 negative of -1, positive of 3, negative of 1. So total answer कितना हुआ? This becomes 2 plus 1 eventually. 3 plus 3, 6 minus 1. So this also stands to be 5. Oh, my screen is off. Just a second. It's plugged in now. Yes. Just a second. All fine now. Right. So 2 plus 3, 2 plus 1 plus 3 minus 1. That is also equal to 5. Correct? This is also equal to the 5. All right. Okay. Moving ahead. Okay. Moving ahead. x0, x2. Then what is the value of x1? So x1 we will calculate by the formula. What was the formula? Right. What was the formula? So in general, they mentioned the Fourier transform, Fourier analysis and Fourier transform for discrete time signals in doubly latest syllabus, Ritik. So yes, we can say because it covers everything. You know, they have given the general syllabus, so it automatically covers. Are suddenly 3 students coming and not liking the session. Wow, no issue. So why to attend? Enjoy your Dashera. Enjoy your Dashera. No issues, na? Why to worry? So guys, have a look into this. What is x1? I'll go to the general formula for the problem. मैंने क्या बोला था? What is the general formula here? Summation of xn minus j की power kn. Summation of xn minus j की power kn. So it will become summation of xn minus j raised to the power kn. K का value 1 रखा. So open up this summation, guys. N equal to 0. What is the x0? 2 into minus j की power 0 plus next value minus 1 into minus j की power 1. N equal to 0, 1, 2, 3 summation कर रहे हैं plus 2 minus j की power 2. Next value is, sorry, ये 2 नहीं है, this is 3, this is 3 and next is 1 into minus j raised to the power 3. 0, 1, 2, 3 and the values of the samples are available, right? So this is 2 minus of minus j will become plus j. Minus j ka square is minus 1, so this is minus 3 and then minus of j cube will become actually plus j. So this is minus 1 plus 2j, right? This is known as minus 1 plus 2j. Correct, Naren Prasad? Correct. Okay. Surya, the name is written for the class, no need to worry for that. So minus 1 plus 2j. Minus 1 plus 2j. Okay. Now, what is next left in front of me? What is only left? What is only left is x3. Do I need to calculate x3 separately? Do you need to calculate x3 separately? Actually not. I will tell you a property. I'm just going to start the property, but I'll actually tell you x of 3 you don't have to calculate separately because xn here is a real signal. Xn here is a real signal. So always remember that x of k can always be equal to x conjugate n minus k. Conjugate symmetry property I will list down under the property. I will list it under the property officially. Okay, let us use it right now. X of k is equal to x star n minus k means x of 3 is equal to x conjugate 4 minus 3. That means x conjugate of 1. What was x of 1, sir? Minus 1 plus 2j. Just take the conjugate. Minus 1 plus 2j का whole conjugate is minus 1 minus 2j. Finish. That is what you have to do actually. Okay, so you don't have to calculate x3. So suppose if there is a 4-point DFT coming. Okay, suppose if there is a 4-point DFT coming. Okay, there are 90% chances that your option will match only by these two values. Which value? First ordinate and central ordinate. 90% chance hai. If it is a direct 4-point DFT question, you can match your options by first and central ordinate. If not, so see, there is only one calculation that you have to do. Actually, one calculation. Rest is very simple. What is that calculation? x1. Okay, x1. What is the x3? X star 1. What is x0 and xn by 2? That is very simple. Addition. Okay, direct addition and alternate plus minus addition. So basically, very little effort in 4-point DFT. You have the very little effort in the 4-point DFT. The x of 3 is -1 minus 2j. That means, what is the 4-point DFT? Answer likhenge officially. So what is the answer? What was x0? The x0 was equal to 5. Then x1 -1 plus 2j. Then x of 2 again 5. And then -1 minus 2j. Right. 5 -1 plus 2j, 5 -1 minus 2j. That's it. All right, that's it. Chalo, cool. Now let's view some of the properties, like 2-3 properties I have already briefed inside the question. Okay, the property of xk is equal to x star n minus k, conjugate symmetry property, and then the first ordinate and the central ordinate property. So let us list down all the properties. I will also tell you in today's class what is the meaning of circular shift, circular fold, and also what is the circular convolution. Automatically, when we are studying the DFT, circular convolution will also be covered for you. Don't worry. Circular convolution bhi cover kar lenge hum. Everything will be covered within this concept. Okay. So some properties. The basic property, linearity, as always, very simple. The DFT of a1x1 plus a2x2 should be equal to a1x1k plus a2x2k. That is very simple. Like all the type of Fourier transform, linearity is applicable. When you add two signals, the DFTs are added. Acha ji. ठीक है. सर्क्यूलर टाइम शिफ्ट. नाउ फर्स्ट ऑफ ऑल, व्हाट इज द मीनिंग ऑफ सर्क्यूलर टाइम शिफ्ट, ये भी हम अंडरस्टैंड करेंगे. व्हाट इज द मीनिंग ऑफ सर्क्यूलर टाइम शिफ्ट? लेट अस अंडरस्टैंड टाइम शिफ्ट फर्स्ट एंड देन वी विल कम टू दिस फॉर्मूलाज एंड ऑल. देन वी विल कम टू द फॉर्मूलाज. देखो, सपोज अंडरस्टैंड, लेट xn, let me take randomly, suppose it is 1 2 3 4, just randomly I taking 1 2 3 4. What is the meaning of circular shifting and how to do it? First I will sketch graphically and then I will explain you, verbally. It's easy to do the circular shift. So guys, we know that xn be periodic. The DFT and IDFT are both periodic with period 4. Are both periodic with period 4. It's a 4-point signal, so I will take it as periodic with n equal to 4. Okay, now look at this sketch with me. एक छोटा सा स्केच आप कंसिडर करना मेरे साथ. यू विल गेट होल्ड ऑफ द आइडिया. Okay, we'll get hold of the idea if you just do a very small sketching in front of me, because it is periodic, because it is the periodic. Okay, ठीक है, ध्यान देते चलेंगे. The first sample is equal to 1, right? Then the next sample, the first sample is simply 1, the next sample is equal to 2, the next is equal to 3, the next is equal to 4. And because it is periodic, it will repeat henceforth, and then again it will be 1, then again it will be 2, then again it is going to be 3, again it is going to be 4. Of course there has to be repetitions on the left hand side also. Suppose this is 4, reverse में लिख रहे हैं, then this will be equal to the 3, and etc etc etc. Understand the concept of, first of all, circular shift, right? Yes, Kanugula, that is what. If you remember the discrete frequency, properties will be very simple. So property पे जाने के पहले I am first explaining you, okay, if this is a signal xn, what do you mean by the circular shift version of this? Circular shift and circular fold, both we will consider here. So suppose guys, suppose here I want to sketch, okay, here I just want to sketch its shifted version. Here I just want to sketch its shifted version. let us consider this. Okay. So guys, suppose if I want you to sketch x of n minus 1, what will be x of n minus 1? Let's do the linear shifting. Let us first randomly try the linear shifting and then I will give you the trick. If you just want to do the linear shift by 1 unit, kitna unit? 1 unit. So this is 1, 2, 3, 4 and this is the origin 0, then 1, then 2, then 3, then 4, 5, 6, 7 and repeats. It's periodic with the period equal to 4 and for such periodic signals we can apply the circular time shift. Let's do the linear shift. So what is the meaning of the linear shift? What is the meaning of the linear shift? इसको ऐसे ही कर देते हैं quickly. What is the meaning of linear shift? The sample 4 will come here. Then what will come? Then 1, then 2, then 3, right? And then again 4. Right shifted by 1, na? Okay, so this is 1, 2, 3, 4. Okay, left of this will be 3. This is again 4, then 3, and then 2. And here again 1. I told you one thing, because the DFT and IDFT are periodic with period n, so we only consider the values from 0 to n minus 1. We will only consider their values from the 0 to n minus 1. So if you take the values from the origin, values लिख देता हूं मैं यहाँ पे, ये लीजिए. This is origin 0, then 1, then 2, then 3. And if you consider the values only for the one time period 0 से लेके n minus 1, 0 से लेके 3, what is that you are getting? If you consider their values, this much of the values only from 0, 1, 2, 3. So what are the values obtained? So I can write down x of n minus 1 for one period is equal to 4, 1, 2, 3. 4, 1, 2, 3, isn't it? 4, 1, 2, 3. Basically the idea is the xn is equal to 1, 2, 3, 4. If I want you to write x of n minus 1 mod 4. Now this is what is known as circular shift. Why it is circular shift? Because of periodicity the circular pattern is coming. Okay, because of the periodicity. Okay, आपको क्या लग रहा है कि ये जो 4 है, what we are looking into, what is the answer? Let me write down the answer here. 4, 1, 2, 3. 4. Oh, what is this happened? Sorry. 4, 1, 2, 3. This is the answer. See, actually what has happened, what you might be feeling, sir, kya ho gaya? This 4 goes here, it comes here in the circular form. It's like a circular shift. But why it is actually circular shift? What is the logic behind circular shift? Ki first I have done the regular shift. First I have done the linear shift. Okay, but because of the periodicity of the signal, ye jo 4 tha na, this 4 goes forward only. It is not going backward. Okay, but there was one more 4 in the queue. There was one more 4 in the queue that comes forward. Okay, तो हमें क्या दिखाई देगा? हमें ऐसा लगेगा कि ये 4 यहां पे आ गया. That is what is the appearance, and that is why we call it as a circular shift. That is why we call it as a circular shift. So now, whenever there is a circular shifting required, you don't have to sketch the graph. Okay, you don't have to sketch the graph. You just have to, okay, do the shifting in this manner. Example लेता हूं मैं. Okay, and we represent the circular shift as x of n minus 1 mod 4. This is the representation of circular shift. So if I want to ask you one question, suppose let's apply it on a 8-point signal. Right. If I want you to write down the value of x of n minus 2. If I want you to write down the value of x of n minus 2, what will be the value of x of n minus 2? What will be the value of x of n minus 2? X of n minus 2 kaisa? X of n minus 2 mod 4, mod 8. Here the length of the signal is 8. And if I want you to write down what should be x of n plus 3, it could be right shift, it could be left shift. Nah? Okay, very simple. Now, do I need to sketch the graph? Absolutely not. Can you write down the values very, very quickly? How to do the circular shift? How to do this circular shift? To see the answer with me. देखो, logic and shortcut ऐसा बोलता है. Yes, exactly. The number of samples in one period Kanugula, correct. So if I want to write down this answer, I will have the answer as, see, suppose imagine that everybody will know na n minus 2 means right shift. That is clear to everyone. So suppose you want to do the right shift, But your limitation in DFT is only from 0 to n minus 1. Okay, so if you want to right shift, 7 and 11 will come here. But you don't have any extra space. Trick bata raha hu, logic and trick. You don't have any extra space here. So they will circularly rotate and come in the beginning. So whatever has to go to the last, circular form mein aa jayega beginning pe. That is how you can write down the answer. Okay, so last two samples will come to the beginning in the same sequence. Right, last two will come in the beginning in the same sequence, 7, 11, then minus 1, 2, 5, 3, 2, minus 6, that's it. Do I need to sketch? No, it is a 5 seconds question for me. It is a 5 seconds question for me, right? Now n plus 3, left shift. Now when you want to do left shift, see, you don't have any space here. Okay, so how many samples you need to left shift? 3 samples. So what will happen? They will go from the beginning to the end. They will go from the beginning to the end. Like that you can remember, na? Bhai, you have to assume that whenever it is a 8-point signal, you only have the space from 0 to 7. Okay, neither you can write down anything to the left, neither you can write down anything to the right. So whatever is going right, usko वापस left में adjust करो. If something is going to the left, go and adjust to the right at the end. Right. So that is what you can remember here. तो चलो answer लिख देते हैं. So my answer will be minus 1, 2, 5. तो बाद में जाएगा. We'll start from here 3. So it should be 3, 2, minus 6 and 7 and 11, and then minus 1, 2 and 5 in the same sequence. Okay, they'll follow the same sequence. Right, that is what is known as the left shift. So this is circular right shift and circular left shift. Acha, one more question here. This is question number 1, this is question number 2, and there is question number 3 here. What is the question number 3? What is the question number 3 for the same question? What is the value of x minus n mod 8? Now everyone knows x minus n means folding, but I want to represent circular folding. Understand इसी example से करते हैं. What is the meaning of circular folding? Understand with the same example. What is the meaning of this circular folding? Understand with the same example, and then we apply to the 8-point signal. सर्कुलर फोल्डिंग को समझ लेते हैं सेम एग्जांपल के साथ. दिस इज इक्वल टू x ऑफ माइनस n. आई वांट टू स्केच x ऑफ माइनस n. लेट अस फर्स्ट डू द रेगुलर फोल्डिंग. पहले सब कुछ नॉर्मल जो आता है ना, जो देखा देखा सा है, पहले वही करेंगे. ओके, जो देखा देखा सुना सुना सा है, पहले उसी पे ट्रस्ट करेंगे. राइट, सो व्हाट इज द मीनिंग ऑफ फोल्डिंग? ओके, राइट टू लेफ्ट एंड लेफ्ट टू राइट. सो ओरिजिन विल बी एज इट इज. The origin sample will be as it is, usme there is no doubt. This remains, seedha ho ja. This remains as it is. Then this 2 goes here actually, right? Then comes 3, then comes 4. So it has been folded right to left. So of course left wala will come to the right. 4 will come here, right? Then 3 will come here. Right, then after 3 what it should be, yahan pe of course 2 hona chahiye na. So then 2 will come, go left, 4, 3, 2. Next should be 1, so 1 will come here. Next is the turn of 1, and like that. What is my constraint? I will consider, ye ho gaya 4, 3, 2, 1. This is 2, 3, 4 in the reverse order. My constraint is that I will consider the sample only for one period, that is 0 se n minus 1. I will consider 0 se n minus 1. This is what is known as circular shift. So what is x minus n here? What is the x minus n here? You get 1, 4, 3, 2. That is what is known as circular folding. That is what is known as circular folding. Now try to understand. यहाँ पे लिख देता हूं मैं. So what was my signal xn? My signal xn, which is 1, 2, 3, 4. It's circular folded form. X of minus n mod n, x of minus n mod 4 is also known as, या mod n ही लिख लेते हैं, is also known as x of n minus n. There is also one more way of writing. It is also known as x of n minus n. Yes, correct, Naren Prasad. And what is the answer? Then the technique. What is the answer? Look into this. 1, 4, 3, 2. The answer is, sir, it is 1, then 4, then 3, and then 2. 1, 4, 3, 2. Right. अब आप देखो. what you have to do in the circular folding, separate the origin, separate the first sample always, right? And let's say you have a mirror, ऐसा करना है यहाँ पे, let's say इसको separate किया, and let's say you have a mirror where you have a mirror at n by 2 at the central ordinate. Suppose you have a mirror at the central ordinate at the n by 2. Now what is the role of mirror? What is the role of mirror? To create reflections. What is the role of mirror? To create reflections. Swap left to right, right to left. But mirror is at the central ordinate n by 2 and origin को separate रखना है. So just swap 2 and 4. You get the answer. आ गई बात समझ में? Just swap 2 and 4. You get the answer. You get the answer. Let us apply it to this 8-point signal. Quickly guys, maybe 20-30 seconds. Can you write down the x minus n here? X minus n mod 8 for this question. Can you write down quickly? What is the x minus n mod n for the same question? So we have covered up circular time shift and circular folding. Now we will jump back to the properties, right? We will jump back to the properties. Yes guys. Chalo. Let's check it up. I think 20-30 seconds are done. So let's see what is the answer. So see what is the xn. What is the xn? Let me write down the xn once. क्या given है? -1 2 5, -1 2 5, 3 2 -6. And we have 7 11, right? So everybody answer. Separate the origin. Where should be the mirror? Mirror at n by 2. What is n by 2 here? 4. The total length of the signal is 8. 8 by 2 is equal to 4. So start from origin 0 1 2 3 4. This is the mirror. This is known as the mirror. Mirror at n by 2. Okay, this is the mirror at 4. Now what is the role of mirror? To create the reflection. Swap 3 and -6, swap 5 and 7, swap 2 and 6. जो दूर पे होगा वो दूर वाले से रिफ्लेक्शन बनाएगा ना. या simple, right to left, left to right, folding. You can perform the folding as well. So what is my answer? My answer xn becomes -1 as it is, and then सबसे पहले 11 7 -6 reverse. Okay, then mirror as it is, then 3, then 5, and then 2 should be the answer. This is how we do the circular fold. In some indirect questions, you may be required to do circular folding also. So we must know the technique. DFT में पूरा comfortable होना है तो we must know circular time shift, we must know circular folding, and we must know circular convolution. Circular convolution. That also I will explain you. Circular convolution भी आज की क्लास में कवर करने वाले हैं. -1 11 7 -6 2 3 5 2. Yes, done. All done. All set, I think. All set. Chalo. Okay. Oh, sorry. I have written xn here. I'm sorry. This is x of -n mod 8. X of -n mod 8. Right. Okay. Moving ahead now. So we'll come back to the property. Okay. What is a circular time shift property? Property, you don't have to remember anything else. कुछ भी अलग याद नहीं रखना है. See, I will make you remember very simply. If xn has the DFT xk, what is the DFT of x of n minus n naught? यही बोला गया है ना, x of n minus n naught. What is the regular? What is the regular answer? What is the regular answer for any Fourier transform? Time shift corresponds to phase term, exponential term in the frequency domain. So it should be x of k e raised to the power minus j omega n naught. That is what should be the answer na, for any type of Fourier transform. Which omega? Which omega? Only thing is, whenever it is a DFT property, it should be, whenever it is a DFT property, it should be x omega k, discrete frequency. So you get your property. So you get your property. Okay. Whenever it is DFT, discrete frequency, and which shifting? Circular shifting. mod n. So what is this answer actually? X of k. Now do I remember the discrete frequency formula or not? Do I remember the discrete frequency formula? Yes, I remember the discrete frequency formula. So it becomes e power minus j. What is the discrete frequency? 2 pi by n into k n naught. यही तो लिखा है ऊपर. Look into this. E power minus j 2 pi by n naught k, यहाँ k n naught. So do you need to remember the property separately? No. I remember it already, sir. We remember whether it is Fourier transform, continuous or discrete. We know if it is a time shift, there will be a phase term, exponential term, e power minus j omega n naught. Finished. Question is finished. The property is finished. Similarly, let's go to the property of, okay, frequency shifting, vice versa of this. Frequency shift, time mein exponential term. How we will remember this? Okay, if x of n having the DFT x of k, so when I want to do the frequency shifting, x of k minus k naught, x of k minus k naught, okay, so what it should be? In the time there will be an exponential term. Minus k naught, only remember in the frequency shift sign opposite hota hai. Okay, if it is minus k naught here, it should be plus. So e power plus j omega n. Which omega? Omega k. केवल प्रॉपर्टी को कॉपी कर दिया, replace the omega by omega k. Okay. So to be honest, I also remember by this method only, and I know what is omega k. What is the concept of discrete frequency? ये मेरे mind में मेरे को clear है. So what is the omega k? It becomes e power j 2 pi by n k naught. K should be k naught and then n. ऊपर यही लिखा है e power j 2 pi by n k naught n. That's it. Simple. Okay. So whatever is k naught, यहाँ पे भी k naught रहेगा. Okay. So we don't have to remember anything separately. Acha, one more thing. This will again because xn and xk, DFT, IDFT are both periodic, and both periodic means whenever you say shifting, whether time shift or frequency shift, it has to be circular shift. Okay, circular folding. Okay. If, what do you remember for DFT? X minus n has the DFT x minus omega. The same thing will come up here. Time shift corresponds to time folding corresponds to frequency folding. So x minus n will have the DFT. Oh, this is capital X, of course. This is capital X. X minus n have the DFT x minus k. यही property आपने पहले भी पढ़ा होगा. If it is time folding, then it is also the frequency folding. Time folding corresponds to the frequency folding. X minus n corresponds to x minus k, but both will be circular folded. Okay. Both will be circular folded. What is circular folding? I think already we have understood. Circular folding is already understood for us. Now, coming to the symmetry property. What is the symmetry property? Same as the DTFTs or the CTFTs. क्या है symmetry property? If x of n has the DFT x of k. If x of n has the DFT x of k, then x conjugate n, the conjugate of the signal, has the DFT x conjugate minus k. This is what is the DFT of conjugate of a signal. Okay, इसको भी separately लिख देते हैं. What is the DFT of conjugate of a signal? X star n has the DFT x star minus k. Now, if a signal is real, okay, if a signal is real, what is the meaning of real signal? The signal and its conjugate will be same. X star n will be equal to the xn. So what is the value of x star n? X star minus k will be equal to xk, correct? X star minus k will be equal to the xk, right? Or I can say that x of minus k will be equal to x star k. But whenever you write down minus k, you should always be aware that minus k means folding. Which folding? Automatically circular folding should be there. X star minus k mod n. Circular folding will be followed. Okay. सर्कुलर फोल्डिंग, तो यहां पे भी मैं क्या लिखूंगा, mod n, राइट राइट, यहां पे भी हम लिखेंगे mod n, राइट. सो दैट मीन्स what is the value of x minus k mod n? One more thing I have told you, x minus k mod n, which is also x of n minus k with the circular folding concept. मैंने ये भी आपको बोला था, that is equal to x n minus k and that is equal to x star k, that is equal to x star k. Or finally I will put it like this, x of k is equal to x conjugate n minus k. That is actually the property I already used in the question. Na? ये property already used in the question to calculate x3. For example, if you have n equal to 4, right? If you have n equal to 4, you need to calculate x0, you need to calculate x1, you need to calculate x2. ये calculation आपको करना है. But what about x3? x3 is just x conjugate 4 minus 3, x conjugate n minus k, and that is x conjugate 1. That can be derived using x1. You don't have to calculate x3. Already used in the question. Na? Same thing we have already used in the question earlier. यही हमने use किया था. x3 is x conjugate 1. Everybody. Okay. If it is n equal to 8, ये ध्यान देना. Suppose if it is n equal to 8. Okay, calculate x0, calculate up to the central ordinate, x0, x1, x2, x3, x4, यहां तक calculate करना है आपको. But what is x5? It is x conjugate. 8 minus 5. It is x conjugate 8 minus 5, which will be 3. 1 second again, the screen. Just 1 second. Right. X conjugate 3. Then what will be x6? X conjugate 2. And there are questions in the exam based on this property. What is x7? X conjugate 8 minus 7. That means x5 can be obtained by x3. x6 can be obtained by x2. x7 can be obtained by x1. Can we place it as a mirror property again? Okay, ये ध्यान देना. So conjugate symmetry property suggests, that is what I have already told you. The conjugate symmetry property suggests we need to compute only half. Actually, not exactly half. N by 2 plus 1. For example, if you look into this. Okay, if you look into this, what is the 8 by 2? Is 4. So we calculate up to 4. But we are starting from 0. So how many values we need to calculate? 0 plus 4, that is 5 values. Rest you don't have to calculate. So if it is a 8-point DFT, you don't have to calculate all 8 points. You have to calculate only up to x4. That is what this property says, that the conjugate symmetry property suggests that we need to compute only half, precisely n by 2 plus 1, not exactly half plus 1. Okay, of the DFT values to find the entire DFT sequence. And this effect will be big if n is big. Suppose somebody is trying to calculate 1024-point DFT. Somebody is trying to compute the 1024-point DFT. So in the 1024-point DFT, how many values you need to calculate? 1024 by 2 plus 1, that will be 513. 511 computations saved. So nearly half, 511 computations saved. They will just be obtained by conjugate. Okay. So at least you don't have to solve that summation, summation xn w power kn. That is saved for you. इतना सारा बच जाएगा आपके लिए. Correct? 511 computations will be saved for you. That is what is the conjugate symmetry property. That is what actually I have just briefed in front of you. Okay, so what we can say that here, what I can say here is that this n by 2, now this n by 2 can be known as a conjugate mirror. Not a mirror, but I can call it as a conjugate mirror. Just like folding, just like the folding I explained you, separate the origin. Just like the folding I explained you, separate the origin, and rest of the values are related to each other through conjugate. Okay, यहाँ पे there is one more thing I should place is conjugate. X5 is conjugate of X3, right? X6 is conjugate of X2. X7 is conjugate of X1. That is what conjugate symmetry property will save you nearly half of the values. Okay, and there can be property based question. There can be property based question that you can expect from this conjugate symmetry properties, everybody. Okay, next. Some more common properties you know for Fourier transform, that is just repeated here. If xn is real and even, the DFT is also real and even, same as the earlier Fourier transform. So let's not derive and repeat it. इसको directly बस review कर लेते हैं. If a signal is real and even, the Fourier transform is also real and even. If a signal is real and odd, the Fourier transform is pure imaginary and odd. Right? If you consider the even part of the signal, Fourier transform will be real part of xk. For odd part of the signal, Fourier transform will be j imaginary part of xk. Same as the CTFTs and the DTFTs, so nothing new here. Okay, now again come to the very, very important point, circular convolution. First understand how to do the circular convolution. Property again same hai, property nothing new. कुछ भी नया नहीं देख रहे हो. Actually, if you see from the property 1 till here, there is nothing new in the properties as of now. Okay, there is nothing new in the property as of now. Convolution in time, multiplication in frequency. X1n conjugate X2n is X1k into X2k. Conjugate in time, convolution in time is multiplication in frequency. Vice versa, multiplication in time is convolution in the frequency domain. So X1 and X2n has the DFT 1 upon n X1k conjugate with the X2k. 1 upon n X1k conjugate with the X2k, everybody. Correct? Chalo, that is what it is. Okay, but how to do the circular convolution? What is the technique for the circular convolution? Us pe aate hain. Yeah, let me just wind up the properties and then I will give you the circular. Everything is almost done. Central ordinate, this is important, but this is already discussed. Okay, this is already discussed. The central ordinates and the starting ordinates. X0 is summation xn. Remember, beginning only we discussed the same property. And x of n by 2, central ordinate. Alternate sign wala, x0 minus x1 plus x2 minus x3 and etc. This is already discussed. Okay, इस पे हमने question भी solve कर लिया already. Okay, duality. Let me just complete up 1 or 2 properties and then I will jump back to the circular convolution. उस पे detailed discussion करेंगे. Okay, if xn has the DFT xk, x of n will have the DFT n x minus k. X minus k means circular folding again. Duality. Okay, although I don't see much of it coming up in the questions. Okay, and Parseval's energy relation. The energy in the time domain is given by summation of mod xn square, and from the Parseval's relation it will be given by 1 upon n summation mod of xk square. So sometimes they can give you xk. Directly they can give you only xa. A signal xn has the DFT xk. Find the energy of the signal xn. So 1 upon n summation of mod xk square. 1 upon n summation of mod xk square. Chalo. So now we will go towards the question, but only one thing I need to explain, circular convolution. After that, all property based and indirect and tricky questions will be covered up in the session. X1n conjugate X2n has the DFT X1k, X2k. Property is same. Convolution in time, multiplication in frequency. But how to do the circular convolution? Actually, how do you do the linear convolution? The regular convolution, also known as the linear convolution. So what is the linear convolution formula? We write down y of n, which is x of n. The output of a system is the input convolution with the impulse response of the system, and that is given by the formula summation of xk h of n minus k from k equal to minus infinity to the infinity. That is what is the linear convolution. Linear convolution. Yes, Kanugula. The period 2 pi was the period in DTFT. Here the period is n. Achha. For periodic signals, whenever you have periodic signals, okay, we will always follow the circular convolution. Actually, linear convolution will not converge for the periodic signals. The summation of the linear convolution will not converge if a signal is periodic, and we write down the circular convolution as the very similar formula, only few changes. Dhyan dena. It is summation of xk h of n minus k. Summation of xk h of n minus k. Okay. But h of n minus k represents a shifting type of term, shifting and folding. So what shifting and what folding? What shifting and what folding? Circular shift and circular fold. So just write down for formality mod n. Okay. Now in general the limit of the convolution is minus infinity to infinity, but in the DFTs, in the IDFTs, we consider the signal only for one time period, 0 say n minus 1. Right. So the limit will be 0 say n minus 1. How to solve circular convolution? Do I need to solve by the formula? No. Just tell me, everybody in the comment box, tell me, how do you solve the linear convolution, okay, for discrete time finite length signal? We are going to cover finite length signal. Na? Whenever it is a discrete time finite length signal, how do you solve the convolution? Regular convolution. Method बता दो. एक simple सा method का name होता है. Can you tell me that method? How do you solve the convolution, the regular linear convolution of finite length discrete signals? Tell me. I'm just waiting for the comments. बता दो मेरे को. Tell me. Yes guys. How do you solve the method? What is the method? Name of the method. Very simple method जो आपने follow किया होगा अभी तक. It's actually very simple method. Right? Yes, the tabular method. Somebody can call it as grid method also. Correct. The tabular method, also known as the sum by column method, simply known as tabular method. Very good guys. Okay. उसी method को हम use करेंगे. Everybody I think will be comfortable with the tabular method. Same method I will use. Okay. Let's do a circular convolution question. Forget the DFT. Forget the DFT for a moment. Let us only focus on the circular convolution for a moment. Okay. Suppose xn is given to you as 2, 3, minus 1, 4, a 4-point signal. Hn is given to you as 1, minus 2, 0 and 3, 0 and 5, whatever it may be. Okay, we need to write down what is x of n circular convolution. Now what is the symbol for the circular convolution? मैंने यहाँ रखा कि नहीं? What is actually symbol? Xn circular convolution with Hn. Xn circular convolution with Hn. Okay, we will apply the same tabular method. What tabular method? यहाँ पे ध्यान देना मेरे साथ. Okay, I will write down any one of the signal on the top, because convolution is always commutative, na? You can interchange the operands. Okay, so let us write down any one of the variable on the top, any one of the signal on the top, 2, 3, minus 1 and 4, and write down the other one, 1, minus 2, 0 and 5 here. Then what do you do? एक काम करते हैं, for a moment let us solve the regular tabular method. Let us solve by the regular tabular method. So what we will do, I will multiply 1 by all of these elements. So 1 into 2, 1 into 3, 1 into minus 1, 1 into 4 will be 4. So it will just repeat. Okay, that is what is the regular method we know. Okay, now next what I will do, I will multiply by minus 2 and I will write down the results 1 unit right. So minus 2 into 2, minus 4, minus 2 into 3, minus 6, minus 2 minus 1, plus 2, minus 2 into 4, minus 8. अभी केवल ऐसा लिखते चलो, just keep on writing like this. Regular method. Then 0 into everything will be 0. So 0, 0, 0, 0. Next is 5. So 5 2s are 10. 5 3s are 15. 5 into minus 1, minus 5. And 5 4s are 20. 5 4s are 20. Everybody. Okay. Now I want to write down the result of the convolution. So what I will do is now, the sum by column. Arey yaar. What I will now do is the sum by column. Okay, sum by column. We will sum every column. So what should be the answer here? 2. What should be the answer here? -1. What should be the answer here? Etc. etc. This is a regular convolution. Lekin what do we do in the circular convolution? Just a small change here. What do we do in the circular convolution? Hamesha, every time, one thing in the brain. In the DFTs and IDFTs, we cover up the signal only from 0 to n-1. That is what is my foundation. That is what led to the idea of circular folding. That is what led to the idea of circular shifting. Same thing will give the idea of circular convolution. We are always bounded from 0 to n-1. We are always bounded from 0 to 3. Only 4 samples we can cover. तो यहाँ पे एक boundary बनाई मैंने. यहाँ पे एक boundary बनाई. Only 4 samples I can cover. And what about the remaining? Only 4 samples I can cover. And what about these remaining guys? क्या करेंगे? Should I discard them? No. No, don't discard them. See, actually what you have done is a right shift. Na? What you have done is a right shift. Don't do right shift. Do the circular shift. Do the circular shift. Now, what is the meaning of circular shift? That the sample which was going to the right, इसको घुमा फिरा के यहाँ place कर दो ना. इसको घुमा फिरा के यहाँ place कर दो. That is what circular shifting I explained you ना. Apply the circular shifting here. So whatever a sample is going to the out, circularly shift and bring it here. ये आ गया -8. Then 0 0 0 0. Next 15 -5 20 in the same sequence. यहाँ आ जाएगा 15 -5 and 20. 15 -5 and 20, right? Done. Circular folding, circular shifting, sorry. That is just the circular shifting, nothing else. Now do the sum by column. Now do the sum by column. So here it is my answer. 2 plus 15, 17 minus 8, 9. Right. -5 minus 4, -9 plus 3, -6. 20 minus 7, 13. 10 plus 6, 16. So what is the answer for this question? What is the circular convolution answer? Sir, it is equal to 9 minus 6, 1, 3, 13 and 16. 9 minus 6, 13, 16. Very same idea. Nothing new. So in the circular convolution also you can go for the tabular method and whatever samples were right shifted, na, jo right mein jana tha, do the circular shifting. Do the circular shifting. Right? Right. If everybody clear or not, let me test. Let me test everybody is clear or not. मुझे पता कैसे चलेगा, समझ में आया कि नहीं? I'll give you one question. Okay, मुझे पता भी तो चलना चाहिए ना. I should also get the clarity from your side, acknowledgement from your side. Xn, circular convolution Hn, values I want quickly. I want the circular convolution of them. Xn or Hn ka circular convolution. What is the circular convolution of Xn and Hn? Tell me, what is the circular convolution of Xn and Hn? Circular convolution of Xn and Hn I need, everybody. Yes, circular convolution of the Xn and Hn. Try out everybody, try कर लीजिए और मुझे आंसर बताइए. Yes, come on all. Everybody just keep on trying and give me the answer. Chalo, let me see. Anybody done? Let me see. Okay. So 4, 1, minus 3, 2, 1, 2, 5, minus 1. So 1 4 is a 4. Multiply by 1 to 1. So 4, 1, minus 3 and 2 repeats. Then 2 multiply by 2, 2 4s are 8, 2 1s are 2, 2 into -3 -6, 2 2s are 4. But यहीं पे एक विंडो बना देते हैं पहले से ही. Okay, and whatever sample is going to the right, it will be circularly folded. ठीक है, 4. It will be circularly folded. ठीक है, next. Okay, multiply by 5. So 5 4s are 20. Okay, yeah, if you want you can write it in the last also, no issues. 5 4s are 20, then 5 into 1, 5 into -3 is -15, and 5 into 2 is 10. Okay, so we have the, we'll swap in the last, then -1, so -4, -1, -3, -1 plus 3, and then -2, and now apply the circular folding. Okay, so 4 will come here, -15 and 10 will come here, -1 and 3 and -2 will come here, and now apply the sum by column. Now apply the sum by column. Okay, so -16 and +8, तो -8 से start होना चाहिए. Then I have 10 plus 8, 18 plus 1, 19 plus 3, 22. 2 minus 2 cancel, 20 minus 3, 17. And then I have -10 plus 7, -3. Check out your answers. -8, 22, 17 and -3. -8, 22, 17 and -3. Right. Center वाला 17 है, 1 नहीं है. Some of you are writing it as 1. Please check up once again. Okay, ये 17 आ रहा है. हाँ, that is 17. Correct. Right. -8, 22, 17, -3. Okay, so what is my answer? It is -8, 22, 17, -3. Bolo, circular convolution easy or not? Yes. Now we will go to the property based questions and tricky questions. Okay, we will see the applications of this. Now tell me guys, circular folding, shifting, circular convolution, whether easy or not, show your expressions. Show your expressions. Maybe you can say yes, maybe you can say doubts, maybe you can show up any expression. You have lots of emojis in the YouTube na. Show up your expression. Okay, उसके बाद आगे बढ़ते हैं. It's almost, you know, maybe 1.5 hours of the class, but let's lighten up the session. Let's lighten up the comment box. थोड़ा सा आग लगा दे comment box में. Let me see how enthusiastic you are at 12:40. How enthusiastic you are at 12:40. थोड़ा सा दिखा दो. Just show your enthusiasm right now. Not necessary comments, but any emojis are also acceptable. थोड़ा सा enthusiasm. How enthusiastic are we right now? I'm just waiting for it. I'm just waiting for it. Yes, come on, everybody. Just keep on commenting or express your love by any of the emojis that you can. चलो कूल मज़ा आ रहा है ना. चलो तो मज़ा आना चाहिए. Let the show must go on because it's a non-stop marathon, as I've already told. Now let's go. These properties are already discussed. Now let's come to a question. Consider the signal 2 3 2 1 and find, first of all, simple DFT of xn. We'll start with the simple case and then we will apply some property based questions. Find a DFT of yn equal to xn minus 2 if yk equal to x of k minus 1. See, it is automatically understood. X of n minus 2 means x of n minus 2 mod 4. If yk is xk minus 1 mod 4. If yn is equal to x minus n mod 4. Okay, and etc, etc, etc. So we have 6 questions for one data. So to hold up, to get a good hold on the property. Let's try up. पहले simple try करते हैं first. What is the DFT of xn? What is the DFT of xn? What is the DFT of xn? This should be simple. 2 3 2 1. 2 3 2 1. What is the value of the length of the signal? 4. It's a 4-point signal. So xk, which is in general summation xn w4 power kn, but I remember the value of w4. So for 4-point signal, it is always summation 0 se 3 x of n minus j raised to the power kn. Minus j raised to the power kn. In the 4-point DFT, as discussed, in the 4-point DFT, I have only one effort, that is x1. Baki sab property se aayega. Okay, only one effort. Let us start with that effort. Let us first start with the effort. Rest all will be done easily. Okay. So what is that effort? The effort is only for x1. What is the x1? Summation n equal to 0 से 3 x of n minus j raised to the power n, k की जगह 1 रख दिया, right, and that is equal to, okay, that is equal to how much? So n equal to 0 से start करेंगे. First sample 2 minus j की power 0, then 3 with minus j की power 1. Keep on increasing the minus j power. Next is again 2 minus j की power 2. Next is again 1 minus j की power 3. Right. So this is equal to j power 0 is 1, 2, then minus 3j. Then j square is minus 1, so minus 2, and minus of j cube is again minus j, so this should be plus j. So what is my answer? 2 minus 2 cancelled, minus 2j. Everybody, minus 2j, minus 2j, minus 2j. Right. In which case, Kumar Kokila? In which case, please comment. So I will be elaborating your point then. So it is minus 2j, everybody. x1 aa gaya, it is the minus 2j. Simple. So what is the value of x3 then? What is the value of x3? By the conjugate symmetry property, x3 is conjugate of x1, so that will become plus 2j. Okay. Now rest. What is the value of x0? What is the value of x0? वो तो यहाँ पे लिख लेते हैं separately. It is a very simple formality for me. What is the value of x0? Summation of the sample. 2 plus 3 plus 2 plus 1. Okay, so 5 plus 3, 8. That is equal to the 8. Right? Okay. Then what is the value of x2? Central ordinate. Central ordinate, alternate plus minus, alternate plus minus. Right? No Dhantuluri, I don't think any buffering is going on. Okay, so what it is? Alternate plus minus. So 2, then minus of 3, then plus of 2 and minus of 1. So 4 and minus 4. This is eventually becoming 0. This is eventually becoming 0, right? Chalo. So what is the value of the 4-point DFT? So we have the xk now coming up as xk starting with the first sample 8, then x of 1 minus 2j, then 0, and then plus 2j, and then plus 2j. That's it. Finish. Acha ji, this one is finished. This one is finished. Now let's come to the second question. Find the DFT of yn equal to xn minus 2. Now, what do you think? Whether I should first shift the signal, circular shift the signal, and then find the DFT again? That will be lengthy, na? One method is first shift the signal, find a new signal, and find the DFT. Can become lengthy. So property se jayenge na. These are actually property based questions. So what is the second question? We need the DFT of yn equal to x of n minus 2 mod 4. So what is the property, guys? Time shift. Time shift. The phase term in the frequency, exponential term in the frequency, xk e raised to the power minus j omega k n naught, omega k into 2. Always remember the basic Fourier transform property, e power minus j omega n naught will come. Okay, now replace the omega by discrete omega. So this will be x of k e raised to the power minus j. Okay, omega k kitna hua? 2 pi by 4 into 2. Right? This is nothing but, so I have y of k equal to x of k e raised to the power minus j, 4 and 4 cancel, e power minus j pi, e power minus j pi, cos pi minus j sin pi, cos pi minus j sin pi. Oh sorry, I missed the 2 here, I missed the k here, into 2. So ये कितना हो गया? j e power minus j pi whole raised to the power k. So it will be x of k into minus 1 ki power k. So answer finished. Right? So you have to make the lengths equal corresponding to the length of the higher one, Kumar Kokila, by zero padding. By zero padding. Right? So what is yk? xk minus 1 ki power k. So whatever is the xk, multiply by minus 1 power k correspondingly, and here is your second answer. Here is your second answer. Minus 1 power 0 is 1. So 8 into 1 will be 8. Minus 1 ki power 1. So यहाँ पे sign change हो जाएगा. 0 remains 0. Plus 2j minus 1 power 3 will again change the sign. So this will become minus 2j. This is the answer. Yk. 8, 2j, 0, minus 2j. Right. Any confusion, please tell. I've just applied the property, the time shift, the circular time shift property. Okay, the property is same. Shift in time corresponds to frequency exponential term in the frequency domain, phase term in the frequency domain. Right, good afternoon, Satyendra. So e power minus j omega k into 2, e power minus j 2 pi by 4 into k. What is omega k? Discrete frequency. Very basic of discrete frequency we discussed in the beginning only. So next question. If yk is xk minus 1 mod k, find the value of yn. Chalo, is pe aate hain. Question number 3 now. Question number 3 says, if y of k is equal to x of k minus 1 mod 4, circular shift, circular frequency shift, तो टाइम में एक्सपोनेंशियल टर्म, राइट. सो इफ y के, देखो ऐसा लिखेंगे, इफ xn हैज द DFT xk, सो whose DFT should be x of k minus k naught की जगह 1 आएगा ना, x of k minus 1 mod 4. So frequency shift means phase term in the time domain, e raised to the power plus, it is minus 1, so here it is e power j omega k n. Right, so this will be e raised to the power j, omega is 2 pi by n का वैल्यू 4 है, into k naught का वैल्यू 1 है, multiplied by n. e power j omega k naught, I told you k naught का वैल्यू 1 है, k naught means the circular, the frequency shift parameter. Okay, multiplied by xn. Right, now if this is yk, ये yk है ना, तो this is what is yn. So we have y of n is equal to e power j 2 pi by 4, e power j pi by 2. What is the value of e power j pi by 2? It will be plus j. e power j pi by 2, cos pi by 2 plus j sin pi by 2 निकाल दीजिए, it will come up as j. तो answer is j power n into xn. Question number 3 is solved. What is yn? J power n xn. So just multiply xn by j power n. xn is 2, 3, 2, 1. Okay. 2, 3, 2, 1. That is what is xn. Multiply by j power n correspondingly. तो j power 0, j power 1, ये आ गया j power 2, यहाँ पे आ जाएगा j power 3. So what is the yn? Sir, third question is also solved. It is j power, sorry, ये यहाँ पे j लिख रहा है. This is j power 0 first of all, correct? j power 0 is 1. तो 2 and then 3j and then 2j square minus 2 and j cube is minus j. 2, 3j minus 2 minus j. Answer. And now here I see the intensity of comments going down. मतलब we need to practice, we need to learn here. Simple तक ज़्यादा comments आ रहे थे, यहाँ पे intensity of comment has gone down. So we have to get hold of all of these properties. ठीक है? Okay. xn multiplied by j की power n. Okay, so correspondingly multiply होगा j power n, तो j power 0, j power 1, j power 2, j power 3 multiplied by xn. Everybody. So this is the answer, yn. 2 and 3j and minus 2 and minus j. Chalo, good enough. Next question, question number 4. Find the DFT of yn equal to x minus n mod 4. Okay, so which property? Circular fold property. If yn is equal to x of minus n mod 4, what should be yk? Time fold corresponds to frequency fold. Time fold corresponds to frequency fold. Already we have xk. What is x minus k? Just fold the DFT. What was the xk? What was the xk? First question answer. First question का answer ये रहा 8 minus 2j 0 plus 2j. So what is the answer? What is x minus k mod 4? We know how to do the circular folding now. Everybody, we know how to do the circular folding. Okay, we will just separate the origin and we will place the mirror at n by 2. We will place the mirror at the central ordinate. Okay, so origin separate रखेंगे and mirror will swap the values around it, left to right, right to left, create the reflection. So plus 2j यहाँ आ जाएगा, then 0 and then minus 2j. That is the answer. Simple question, simple answer. 8 2j 0 minus 2j. Correct. बहुत बढ़िया. Right, Tanay, Kanak, Abhi, Kishan, Kanugula. Fantastic. This is the answer. This is the answer for x minus k. Cool. Question number 5. Yes, Arun Kumar, correct. Question number 5. So now we come to the convolution, but actually we will not have to do circular convolution. If yn is xn, circular convolution xn. Question number 5. Question number 5. Y of n is equal to x of n, circular convolution of x of n. Now, what is the convolution property? I have explained you how to do the circular convolution, but need not required here. Okay, how to do the circular convolution Fourier transform? By the property. Convolution in time, multiplication in frequency. So x of k, and it is the same signal. So again x of k. X of k multiplied by x of k, that means x square k. That means x square k. What is the xk? Once again, what is the xk? 8 minus 2j, 0 plus 2j. Okay, so what is the answer for the fifth question? Done. X square k, that is the answer for the fifth question. Y of k, which is equal to the x square k, and the square of this will be 64. Right, 2 square is 4, j square is minus 1, so it will become minus 4, 0 square is 0, and again 2j square, j square being minus 1. 64 minus 4, 0 minus 4. 64 minus 4, 0 minus 4. That's it. So within one question, we are developing all properties, okay? Within one question, we are developing all the properties. Cool. Yk is equal to x square k, 64 minus 4, 0 minus 4. That's it. Okay, fine. Moving ahead. No, Amit. That is in the multiplication property. That is in the multiplication property. Coming up to the next, जो आप 1 by n बोल रहे हो ना, that is in the multiplication property. See, have a look into this. Going to the sixth question and have a look at the property once again. Where is that? Yes. x1n convolution x2n is x1k into x2k, no doubt. When you do x1n into x2n, that is 1 upon n circular convolution of the DFTs. Okay? Chalo. So, yeah, sixth question is actually based on the same. Find the DFT of yn equal to x square n. Sixth question, yn equal to x square n. Sixth question, y of n is equal to x square n. Y of n is equal to the x square n, and x square n can be written as xn into xn. Multiplication in time corresponds to convolution in the frequency domain. Which convolution? Circular convolution. So what is yk? 1 upon n x of k, circular convolution with x of k. Okay, that is equal to 1 upon 4 of the circular, n ka value 4 hai, 1 upon 4 of the circular convolution result. What is the circular convolution? Let's do it up here separately. Let us do it here separately. What is the circular convolution result? Xk convolution xk. So what was the xk? 8 minus 2j, 0 plus 2j. 8 minus 2j, 0 and plus 2j. Okay. 8 minus 2j, 0 and 2j. So let's do the circular convolution of xk with itself. Both will be same. So 8 minus 2j, 8 minus 2j, 0 plus 2j, and the same signal vertically downwards also, that is 8 minus 2j, 0 and plus 2j. Correct? Okay. Let's do it up. 8 8s are 64. 8 into minus 2j, minus 16j. 0. 8 into 2, 16j. Right. Minus 2j into 8, minus 16j. Minus 2j, 2j plus 4. J square is minus 1. Then this is 0. Minus minus plus ho jayega. That will be plus 4. And we will take the boundary here again. We will take the boundary and we will do the circular shifting last mein. Then this is 0, 0, 0, 0. The third one is 0. Now 2j. 2j into 8, 16j. 2j into minus 2j will be plus 4, 2j into 0 is 0, 2j into 2j will be 4j square, which is eventually minus 4. And now do the circular shifting of the samples. Yahan pe aa jayega plus 4, 0, 0 and then 4, 0, minus 4. final answer, sum by column. Okay, so 64, 4, 4, 72. Minus 16, minus 16, minus 32j. Minus 4, minus 4, minus 8. 16, 16, 32j. That is the result of circular convolution. Which one, Kumar? We are going for convolution only here, na? यहाँ पे convolution ही कर रहे हैं. Okay, so 1 upon 4. What is the circular convolution result? एक बार note कर लेंगे. 72 minus 32j minus 8 and plus 32j whole multiplied by 1 by n, matlab 1 by 4. So when I divide by 4, what is the answer for this question eventually? So answer for the last question, y of k is equal to 72 by 4. That should become 18, and then you have minus 8j, minus 8 by 4 minus 2, and then 8j. 18 minus 8j minus 2 and 8j. Correct? That is the answer for the sixth question, and that is complete now. It's just complete. All the parameters are complete. Right. Done. All right. Okay, so with respect to one particular data, we have solved 6 questions covering up circular time shift, circular frequency shift, circular fold, time convolution, frequency convolution. That is time multiplication, which corresponds to frequency convolution. Let's move on towards the next question here. So just a formality, find the endpoint DFT of xn equal to delta n. You know, the delta n, whatever may be, okay. What is the doubt in fifth one, Kanugula? Please say it up. xn convolution, xn, so DFTs were multiplied, that's it. Okay, and देखो DFT, xn, impulse will always have the DFT 1. That means here xk will be equal to 1 for all values of k. For all values of k. That means the DFT of impulse, the endpoint DFT of the impulse will be written as 1 1 1 1 1 1 1 1 1 from k equal to 0 say n minus 1. That's it. We always know that the Fourier transform, no need to derive it, I am just giving you the result. Very easy to derive it actually. Summation delta n w power kn, so it will be summation of 1 into w power 0, it will be always 1. Right. Only n equal to 0 will be considered because it is the delta n. Chalo, so let's go to some more better question then. ये तो हम सबको पता ही है. So a MCQ question, let me see how we have to deal up with the MCQ quickly. How we can deal up with these MCQs quickly. Come on everybody. Yes, Kumar, Kanugula, please say the doubt, it will be more easy. The 4-point discrete Fourier transform. The 4-point discrete Fourier transform of a discrete time sequence. It's a MCQ. Can you give me the answer by the objective approach? ऑब्जेक्टिव में कैसे करना है वैसा कुछ अप्रोच बोल सकते हैं क्या? यस एवरीबॉडी. जस्ट से इट्स आंसर. Can we say its answer by the quick MCQ approach? Okay, so very simple it is. Why it is the very simple? We can just take the endpoint, the central ordinate property. What should be x0? 1 plus 0 plus 2 plus 3, and that is 6. And what should be x of 2? Only central ordinates. 1 minus 0 plus 2 minus 3. So this is 0. So 6 and 0. 6 and 0, option number D. If you combine both of them, you go towards the option number D. 6 and the central ordinate being 0. That's it. Done. So we can get hold of the MCQ questions actually very easily sometimes. Ye ho gaya. Okay. Next, the first 5 points of the 8-point DFT are given to you. First 5 points of the 8-point DFTs of a real valued sequence are given to you. Okay, 5, 1 minus 3j, 0, 3 minus j4, 2 plus j4 and 3 plus j4. What are the last 2 points of the DFT? What are the last 2 points of the DFT? Tell me. What are the last 2 points of the DFT? Right. Yes, guys. Done. Chalo. D or B? D and B commonly coming up. Ab B zyada aa raha hai. It should be a simple question. So the first 5 points, dekho, what is given to you? Let us just write down in the sequence the first 5 points. 5, 1 minus j3. 5, 1 minus j3. 0. 3 minus j4, 2 plus j4, 3 plus j4. First 5 points are given. 1, 2, 3, 4, 5, 6. 6 given actually. I think it's a typo error. 5 and then etc. First 6 points are given. Not the first 5 points, the first 6 points. But actually first 5 points are sufficient. They need not give the 6 points. First 5 points se ho jayega. But here they have given the first 6 points. Very good. No issues. So ye raha 3 plus j4. The last two are missing. Okay. So what I will do? Okay. Conjugate symmetry property. It is based on what? It is based on conjugate symmetry. So separate out the origin and what is the central ordinate? 0, 1, 2, 3, 4. This is what is the conjugate mirror. इसको मैंने define किया था ना. I've defined this as the conjugate mirror. So देखो 3 minus d4, 3 plus j4 already conjugates of each other. So what is my answer now? Okay, 0 conjugate. Answer is 0. Okay, then 1 minus j3 conjugate will be 1 plus j3. So 0 and 1 plus j3. 0 and 1 plus j3. It is clearly B. Some of you were telling D as well. No, it is clearly B. Not exactly C. Not exactly 1 plus j3 तो बिल्कुल नहीं आएगा. 1 minus j3 का conjugate will be 1 plus j3 only. Some of you are telling directly 1 minus j3. ऐसा नहीं है. ठीक है? So it is clearly 1 plus j3. Okay, 0, 1 plus j3. Correct option is option number B. Everybody. The correct answer is the option number B. Cool. Cool enough, simple enough. Let's move on to the next question. Chalo. So here I now give you a question. Where you have to think little bit. It's a GATE 13 2-mark question. It's very simple if you are clear with the concepts. थोड़ा सा सोचना पड़ेगा. The DFT of a vector ABCD is the vector alpha, beta, gamma, delta. मतलब you can take it like this. I will make the data simple. Okay, suppose the DFT of the vector, or call it as the signal xn, if the signal xn is a, b, c, d, then its DFT is xk, and that is given by alpha, beta, gamma, delta. Now consider the product and find the DFT of this vector PQRS. So if you are able to figure out what is PQRS, then you will be able to figure out the data. अब ऐसे एक एक करके, some direct, some twisted, some very good questions will be considered here. Don't worry. Okay, just keep on solving it. Everybody, just take this question and solve and produce the answer. Everybody. Yes. Let me see anybody with the answer. Kishan coming up with the answer first of all. So let me extract थोड़े से और questions भी आप लोग के लिए extract कर लेते हैं. Yes, everybody. So what is this? What is this expression given to you? देखो, let us first try to understand PQRS. Now everybody see, if this is ABCD, what is this vector? Can we try to understand what is this vector ADCB? Can we try to understand this vector? Everybody, यहाँ पे ध्यान देना. So if this is the xn, can you tell me what is x minus n? Do we know the circular folding concept? Do we know the circular folding concept? So yeah, now many of you are coming up with the A answer. Do we know the circular folding concept? What do we do in the circular folding? A ko as it is rakho. Okay. And then this is the mirror. Replace B and swap B and D. So D comes here, C as it is, and B. Sorry. The mirror as it is, and D coming here, and then B going here. ADCB. Is it not ADCB? So whatever is that first column in this matrix is x of minus n. So अब ये तो आपको पता ही होगा ना, how do you multiply two matrix? First row and first column will give you the first sample P. What should be P? First row, first column. Okay, so that means that gives me an idea that P is actually going to be sum of x of minus n and x of minus n. Of course, x of minus n mod 4. Okay, circular folding. Automatically folding means I refer to the circular folding. So what is the P? It is xn into x minus n, everybody. All right. Then next, what is the next column? You just see now, next column is ADCB. Same ADCB, but one unit down, here right shifted. Which type of shifting? Circular shifting. Okay, A, D, C, B should come here, but B has gone top because last mein place nahi hai, so that is known as circular folding, right? So one unit of the circular folding. So first row into second column will give you the value of Q. So sir, what is the value of Q? So I am able to see that Q is equal to x of n into x of, this is the folded version, x minus n. Now one unit right shift. Right shift matlab n replaced by n minus 1. Right shift bole to n replaced by n minus 1. So this is eventually equal to xn into x of, minus ko andar le jayenge to it becomes x1 minus n. This is what is Q, right? Okay, then similarly I can write down PQR. What is R? One more unit right shift. One more unit. Na ye dekho, AD, C also goes to the top. So it is just now shifted. So R will be x of n, x of 2 minus n. 1 ki jagah 2 aa jayega. And PQRS. What is S? X of n, x of 3 minus n. So what is this calculation going on? xn, x of 0 minus n. इसको ऐसा लिख लेते हैं. x of n, x of 0 minus n. यहाँ पे ये hidden हो गया है. The first sample P was xn. The first sample P is actually xn, x of minus n can be written as xn, x of 0 minus n. So xn, x of k minus n. So basically, okay, basically let's say that this vector is some vector yn. Okay, so I can write down the vector yn as PQRS, the signal PQRS, and that is nothing but, कौन सा formula हो गया? Convolution basic formula. Convolution of x with x. Both the signals are x, so it is equal to xn, circular convolution xn. So what should be yk? Indirect circular convolution question. Yk is xk into xk, just like the question number 5. Previous में जो question number 5 किया था, तो what is the yk? It is x square k. It is the square of xk. So alpha, beta, gamma, delta all squared up. Alpha square, beta square, gamma square, delta square. Answer is option number A. Answer is the option number A. Answer is the option number A. Correct? That's what it is. So it's indirect way of writing the circular convolution. This is the circular convolution in the matrix form. We have learned the circular convolution in the tabular form. Calculation ke liye tabular form of course is more handy, more simple, more convenient for the students. Okay. Everybody, this is option number A. A good question for 2 marks, a logical good question for 2 marks. Now, the next question is again simple. Try to understand the question and give me the answer. Consider 2 real sequences with the time origin marked by the bold values. These are the bold values. The first sample is origin again by default. Let x1k, x2k be the 4-point DFTs of x1 and x2. Another sequence x3n is derived by taking the 4-point inverse DFT of x3k equal to x1k into x2k. What is the value of x32? Read. Question is very simple. And such questions are expected for 2 marks. The question is very simple. Please read and answer. Please just read and answer. Yes, guys. Everybody get hold. I'm giving you time for good questions. Let's not hurry up. I want you to try on your own and then I will keep solving. Then I will keep solving for you. Yes, guys. Anybody taking the lead? At least 1 or 2 comments. Solve. Everything is there within the language. Everything is there within the language. Nothing is hidden. Okay, so we have Nikhil coming up with the answer. Right. So Kishan coming up with some different answer. Dhantuluri also coming up with the answer. Yes, everybody. Let's see. Okay, so now much more answers are coming up. Amit, Kanugula, Tane, Arushi, Sok. The common answer that is coming up is 11. Dekho, the answer is hidden here. Another sequence x3n, x3n is derived by taking the 4-point IDFT of x3k equal to x1k into x2k. DFTs are multiplied. Fourier transforms are multiplied. The signal should be convoluted, na? So, agar x3k is x1k into x2k, I should be writing x3n should be circular convolution of x1n with x2n, right? So, the question is on circular convolution again. Okay, so Kishan and Arun says 11 by 4, then many are saying 11, Budepu says 13, x1n circular convolution x2n. Again, based on the circular convolution and linear convolution, there was a question in GATE 21 also, 2 marks question. We will discuss that. So, x1n and x2n are given to you. The x1n and the x2n are given to you. Now, what to do? देखो, हमें केवल इसका circular convolution करना है. So, let us start doing the circular convolution here. What it is? 1, 2, 3, 0. It has been 0 padded actually. 1, 3, 2, 1 to make the lengths same. Okay, as some of you asked in the middle. what it is now, multiply by 1, so 1 2 3 0, multiply by 3, so 3 2s are 6, 3 3s are 9, and then 0. We have multiplied by 2, so 2 into 1, 2 2s are 4, 2 3s are 6, and then 0, and then again 1, so 1 2 3 and 0. Right, so what is my answer? But to write down the answer, we have to first do the circular folding at this window. ये हो जाएगा 0 इधर, 6 and 0 and 2 3 0. What is the answer here? This is 9. This part is equal to 8. Now this part is equal to 11 and this is equal to 14. We want the value of x3, x2, so 0 1 2. This is what is n equal to, ये origin होता है ना, n equal to 0 is the beginning, so this is n equal to 2. So this one is n equal to 2. So what is the value of the convolution at n equal to 2? Answer is 11. Answer is just 11. 11, not 11 by 4. Again, some of you are using the property 1 upon n, but that is there in the time multiplication. When you do the frequency convolution, 1 upon n will come, and it's an NAT question. A small mistake can ruin your answer. If you take 11 by 4, your good knowledge, your good understanding of the question, everything will be spoiled. Answer is 11, not 11 by 4. The final answer will be 11 only. ठीक है, 1 upon 4, मैंने पहले भी बताया था, 1 upon 4 will come when you are doing frequency convolution or time multiplication. यहाँ पे convolution in time domain, so there is no 1 upon n factor. Put that property into the brain. Otherwise, good question. You have every understanding of the language, but finally you are putting up the wrong answer. ऐसा नहीं होना चाहिए. Okay, and with this, let's proceed towards the next question. Let us proceed towards the next question. Which question to take first? Let's take this question. It's simple enough. If you apply the property, it is simple. The solution of this GATE 18 2-mark question, it's a good GATE 18 2-mark question. And let me tell you, the solution of this question in many of the books, you will find extreme lengthy. I'll give you a two-line answer for this. By whatever we have discussed today. Okay. No, Kumar, that is also wrong. Convolution x2k का value फिर वो 11 नहीं होगा ना. That 11 is not 11, that you have to figure out. There 1 by 4 will come, but whether that is 11 or not, that you have to calculate. Na? That also have to take care. It's a good question. I'm telling you, many places you will find a very lengthy solution, but it can be solved very easy. With the extreme ease. If you remember all of the things we have discussed today, if you just remember all of the things that we have discussed today, अगर सारी properties को connected रखोगे, then I think it is easy. Yes, guys. Come on, do take your time. I want you to come up with the answers. I want you to apply the efforts. Efforts आप apply करोगे तो मजा आएगा ज़्यादा. Understanding will be more. With your efforts, understanding will be more. I always believe. Okay. Yes. So Kanugla says 28, Amit says 3. Kishan says 16. So different answers are coming up on the screen. Chalo, no issues. Let's figure out. Time आपको थोड़ा बहुत दे दिया है मैंने. So let xk is equal to k plus 1. The DFT is directly given to me. Be the 8-point DFT of a sequence where xk, that's the definition of DFT we know. What is the value of summation x to n? Let's just work out here. What is the summation? what is the summation 0 से 3 x to n? The question is asking you the summation n equal to 0 से 3 x of the 2n. So place the n equal to 0, x of 0, n equal to 1, it will become x of 2, n equal to 2, so x of 4, and then finally n equal to 3, so x of 6. So all even values of x is required. Okay. Now we will go for the central ordinates property. We will go for the central ordinate property. देखो, what is xk? Xk is given to me as k plus 1. ये देखो ना, DFT is given to me k plus 1 for 0 less than equal to k less than equal to 7. So what is x of 0 guys? X of 0 should be 0 plus 1, but x of 0 का property कितना होता है? And then use the central ordinate k equal to 0 and then go for the central coordinate n by 2. N by 2 means 4. So x of 4 will be 4 plus 1. Right. Now what is x0? The first ordinate, sum of all the values. The first ordinate is sum of all the values. So x0 plus x1 plus x2 up to x7. Right. Central ordinate, alternate sign, na? x1, x0 minus x1 plus x2 minus x3 up to minus x7. So see, automatically what will happen when you add them? This is the simplest approach, and again I am telling you, you will find a very lengthy solution for this question in many of the books. This is the simplest solution, 2-line answer I told you. By our very famous property, the first ordinate and the central ordinate, very, very famous property. So when I add them, okay, just add. What is the x0 plus x4? Okay, when you add, all the odd points will cancel and all the even samples will be doubled. Okay, x0 plus x0. Okay, then x2 plus x2. Then x4 plus x4. Then x6 plus x6. Simple question and simple approach. Okay. So what is the answer? My answer is x0. x0 का value है 1. Plus x4. x4 is 4 plus 1. Whole divide by 2. Yes, 2 is divided. This 2 is divided. Okay, so answer is कितना हुआ? 3. Samyukta has 3. Amit has 3. Fantastic. Okay, so Amit and Samyukta got 3. Rest all some different answers. Isn't it easy for 2 marks? Property based, logic based. जितना properties अच्छा रखोगे, जितना methods को simplified रखोगे, you'll get the benefit in the time. You'll get the benefit in the time in the exam hall. Right? Simple one. Let's move ahead. Let us move ahead to the next one. The discrete Fourier transform DFT of the 4-point sequence is given to you. Okay, xn and xk. If x1k is the DFT of the 12-point sequence, x1n equal to, देखो, 3 2 3 4 is xn, then 3 0 0 2 0 0 3 0 0 4 0 0. First of all, in this question, now one more new concept I will teach you in this question. What is the x1n? What is the value of x1n? Is there any relation between x1n and xn? Is there any relation between x1n and xn? देखोगे ना, 3 2 3 4. 3 2 3 4. Now say what is the relation between x1n and xn? I want your comments first. 3 2 3 4. Same samples are coming up, but zeros are padded. How it is possible? What mathematical expression you can write for x1n and xn? उनके relation को आप कैसे define कर सकते हो? Come on. How you can define their relations? Everybody, tell me through the comments. How you can define their relations? Yes. Right. It's scaling, interpolation. Okay. So basically, okay, when you try to scale, especially expand the signal, when you do x of n by 3, now I am not going for expansion and compression. See, आपको खुद से समझना है. That is the very basics of signal. So I assume that everyone knows what is the expansion or interpolation of the signal. So this is basically x1n equal to xn by 3, and when you expand a discrete time signal, zero paddings come up. That is what is related with the interpolation also. The scaling. Okay, the scaling, the interpolation. So now what is the DFT x1k? So what is the property for interpolation? What is the property for interpolation? I will tell you. First, I will tell you the property. Whenever you have interpolation in time, that will correspond to frequency replication. Okay, I'll tell you the direct property. We don't need to derive it here. That will correspond to frequency replication. Okay, इस पे 2-3 बार गेट पे क्वेश्चन है indirectly on the same point, right? So now, what is this frequency replication? If xn has the DFT xk, right? If xn has the DFT xk, I'll explain you like this. Suppose forget the previous question. Let's come back to a new point first. Suppose xn is ABCD, right? And its DFT xk is alpha, beta, gamma, delta. Suppose that is what is xn and xk. ठीक है. अब if y of n is equal to x of n by 2, okay, if y of n is equal to x of n by 2, expansion by a factor of 2, what is x of n by 2? It will be a 0, b 0, c 0, d 0, expansion by a factor of 2, interpolation again. What will be yk? So sir, as I told you, interpolation in time corresponds to frequency replication. Frequency replication means the DFT yk will be xk मतलब alpha, beta, gamma, delta, alpha, beta, gamma, delta. That is the DFT. Getting it? That is what is frequency replication. Whatever is the DFT, just repeat. Half alpha, beta, gamma, delta, again half alpha, beta, gamma, delta. If it is, थोड़ा generalize करते हैं. If y of n is equal to x of n by 3 मतलब x of n by 3, like in our question, a 0 0, then you have b 0 0, c 0 0, d 0 0. In x of n by 3, 2 zeros will come between every two sample. Then what is the yk? X of n by 3, so 3 times replica, xk is coming up, right? So what is the y of k? Alpha, beta, gamma, delta. Alpha, beta, gamma, delta. Alpha, beta, gamma, delta. 3 times replication, okay? 3 times replication. So that is what is the interpolation property, you must remember. And now let's come back to the question. Now can you give me the answer at least? Now you can give me the answer at least, na? Everybody. Boliye, can you now give me the answer for this? Can we now discuss the answer for this? Come on, everybody. So, what will be x1k? It will be xk. Interpolation है ना, n by 3. So, how many times replica of xk? Okay, 3 times xk will be written. xk. So, what is x1k? Sir, my question is almost solved because xk is given. So, this question wanted to test whether you know the interpolation property in DFT or not. So, that becomes 12, 2j, 0, minus 2j. देखो एक चीज ध्यान देना, point to be noted is कि if a signal is given, you can calculate its DFT. That is also not a new thing. Now we can calculate the DFT, but they don't want you to calculate the DFT. They want you to think about property. The calculation part is given to you. Okay, only properties you need to connect. So replica again, total 3 times लिखना है, and finally one more times. Now, imagine a poor fellow, okay, not knowing this interpolation property. What will that poor fellow do? The poor fellow will think, acha, signal is given, na? I will find x18 and x111. What is the problem? I know the calculation. Of course, everybody knows the calculation, but time. टाइम कंज्यूम हो जाएगा ना. टाइम विल बी स्पेंट अ लॉट, वेस्टेड अ लॉट. आई विल नॉट कॉल इट एज स्पेंट, आई विल कॉल इट एज रादर वेस्टेड. टाइम बहुत सारा वेस्ट हो जाएगा आपका. टाइम विल बी वेस्टेड अ लॉट. So everybody can calculate its DFT. It's a 12-point signal. You want, you can put the efforts and calculate the DFT. But efforts and time will be in vain. Okay. आपके against एक कोई intelligent student होगा, smart student will apply this interpolation approach. Okay. So now it is very simple. Okay. x1k upon x1 11. So this is corresponding to what k? 0, 1, 2, 3, 4, 5, 6, 7, 8. This is of my interest. 9, 10. 11. This is of my interest. So what is my answer? यही लिख देते हैं. My answer is how much? 12 divided by minus 2j whole modulus. Right. So 12 by 2 6 minus j का mod 1 ही रहेगा. तो answer is 6. Isn't it? 6 modulus, not 6j. Kanugula. Modulus लेना है तो it will be just 6. NAT type question. So anyways you can't enter j in the virtual keyboard. Answer has to be a numerical type value. So it is a 6. It is a 6. So if we know that interpolation concept, the question is in my hands. Actually, this is a gate 2 mark question. It is, I think, not mentioned here. I don't remember the year. I'll check and let you know. Exactly the year I'm not able to recall. Somewhere 15-16 के around का होना चाहिए. But I'll check it out and let you know. It's a gate 2 mark question. Okay. Can be solved with ease. It will taking very less time. Because we know the interpolation means frequency replication. We just have to replicate it. The DFT is also given. Okay, maybe 30-40 seconds you can give the answer. If you don't know this, then you will start finding the DFT. Still you can find x1 k8 and x1 11, but maybe it is going to take around 3 or 4 minutes. Wastage of efforts, wastage of time. So that is why in this session, जैसा कि मैंने बोला था, all important properties we are trying to cover, all important cases we are trying to cover. Let us go ahead. Okay. The learning never stops and let us go ahead. Acha ji. Okay. Before going to that, now I want you to give the gate 20 question. Okay. That's actually not typed in that PDF. This PDF में वो typed नहीं है, but I have it in my mobile. I'll give you gate 22 marks question. Gate 20 and gate 21 दोनों का discuss करते हैं. So I'll just write it up here. I'll write down that question here. This question is a gate 2020 2 marks question. What is the question given to me? A finite duration signal. इसके बाद gate 21 का भी लेंगे. A finite duration signal xn. A finite duration signal xn is obtained. It's again a good question. Is obtained by sampling. It is obtained by sampling x of t. Obtained by sampling x of t is equal to cos of 200 pi t. Cos of 200 pi t at the t is equal to n by 400. The sampling time is also given for n equal to 0 to 7, right? The 8-point DFT, the 8-point DFT of the 8-point DFT is xk. Which of the following is true? Which of the following is true? Right. Option number A. Only x2 and x6. Only the x2 and x6 are non-zero. Then I have the option number B. Only x3 and x5 are non-zero. Only the x3 and x5 are non-zero. Are non-zero. Option number C, all xk are non-zero. All the xk are non-zero and only x4 is non-zero. Option number D यहाँ लिख देते हैं. Only x4 is non-zero. Yes guys, can we come up with the answer for this? It's a GATE 2022 marks question. I have noted down that question. It's a GATE 2022 marks question. Chalo, try karte hain isko. And the options are on your screen. You can also try and let me know. Yeah, maybe 1 or 2 minutes of time. Idea is if you try to write down the discrete version of this, okay, it's sampled, the continuous time signal has been sampled to obtain xn. So first write down xn. The sampling time period is also given to you, n by 400. So NTS, when you write down the NTS, that NTS factor is directly given to you. Okay. Now tell me. Now just come up with the answer in front of me. Oh, fine, it's fine. Yes, guys, try to come up with the answer for this question. Okay, chalo, let me start little bit. So what is xn? Can you try to write down what is xn? xt is cos 200 pi t is given to me. Okay. So what will be xn? Okay. What will be xn? So sampling has been done at n by 400, that is the NTS factor is given to you. So what is the signal xn actually? It becomes cos pi by 2n. Cos pi by 2n. It's actually a periodic signal with period 2 pi by 2. That is, the period should be 4, but they want to consider the 8-point DFT. Matlab, again interpolation will come. They want to consider the 8-point DFT. Right? What is xn actually? What is xn actually? Right? What is xn actually for 0 less than equal to n less than equal to 7? I want to consider n equal to 8. So 0 to 7, what is the xn? Dhyan dena. What is the xn? Cos 0 is 1, cos pi by 2 is 0, then cos 3 pi by 2, cos pi will be minus 1, and then next will be cos 3 pi by 2, that is 0. That is a sample for one period. Okay, then it repeats. मैं यहाँ पे note कर देता हूँ ना, this is periodic, right? It is periodic with what period? 2 pi by 2, and that is 4. It's directly an integral time period. It is a periodic with period 4. Okay, but they want to consider the 8-point sample. So 8-point sample ke liye what you have to do? You have to again repeat this 1, 0, minus 1 and 0. 1, 0, minus 1 and 0. Now think further. और क्या कर सकते हैं? Think further. 1, 0, minus 1, 0, 1, 0, minus 1, 0. This is the xn. Either find the 8-point DFT or try to make it little simple. Either try to find the 8-point DFT or try to make it little bit more simpler. थोड़ा सा और simple. Everybody just waiting for your comments, okay? Just try to make it little bit more simple. Already the hints I have given you in the words. What is the hint I have given you? आप देखोगे, you have alternate zeros. You are able to feel that there are alternate zeros. मतलब again it is zero padding case. Zero padding to what signal? Zero padding to what signal? If you take the signal x1n, if you take the signal x1 as an 1 minus 1, 1 minus 1, and then include the zero padding, then your question is solved. 1 minus 1, 1 minus 1. Consider the signal x1n. Okay, so we have some answers coming up now. Right, Amit and Nikhil, but A and B, two different answers are there. Okay, Nikhil also says A. Chalo, great. So this is 1 minus 1, 1 minus 1. So if you try to do the interpolation of x1n by 2, so n by 2, matlab 110 will be padded, and you get the xn. Correct. So xn is x1n by 2. So what should be the DFT? The DFT will be x1k. Frequency replication. Interpolation in time is replication in frequency. But Baba, what is x1k? That's also we can calculate. That also we can calculate in quick time. Okay, so quickly, what is the x1n? What signal is the x1n? 1 minus 1, 1 minus 1. 1 minus 1, 1 minus 1. So what is x1 0? Quickly, addition of ordinate property. तो ये हो गया 0. Central ordinate, first ordinate and central ordinate. What is the central ordinate? Alternate sign के साथ आएगा 1 minus minus 1 plus of 1 minus of minus 1. So everything gets added. That is 4. That is 4, right? What is the value of x11? What is the value of the x11? Correct. What should be the value of x11? So it should be summation of xn, 4 point है ना, तो directly लिखते हैं minus j raised to the power n, minus j raised to the power n from n equal to 0 से 3. Only x1 we need to calculate. Always the efforts are required for x1. So 1 into minus j की power 0, minus 1 into minus j की power 1. Next sample is again 1 minus j power 2. Next is again minus 1 and minus j raised to the power 3. तो ये कितना हो गया? 1 minus minus becoming plus j, minus का square is plus, j square is again minus 1. So minus of minus plus j cube is minus j eventually. So this is actually 0. बहुत कुछ 0 हो जा रहा है ना. See, this is again 0. So what is x13? Conjugate symmetry property. x13 will be x1 star 1. So 0 का conjugate is 0. So what is the x1k? What is the x1k? What is the x1k? 0. Then again 0. Then you have only one non-zero sample, 4, and then again 0. Okay. So here follows my final answer. What is the xk? By the interpolation property, what is the xk? Replication in frequency x1k. This corresponds to the x1k. Let us just copy it. Okay, so 0 0 4 0 0 0 4 0. So which of the samples are non-zero? This corresponds to, okay, k equal to, देख लो ना, k equal to 0 1 2 3 4 5 6 7. Which of the samples are non-zero? 2 and 6. 2 and 6. 2 and 6. Only x2 and x6 are non-zero. Option number A is correct option. बोला था ना, in signals DFT is a topic which can produce good questions. Okay, DFT or Z transform may be mostly simple, but sometimes Z transform also produces very good question. Rest, I believe, the basic convolution part, the sketching of the signals, shifting and all, system properties, signal properties, continuous Fourier transform, continuous Fourier series, you know, DTFTs, all these will produce achievable questions. मतलब वहाँ पे that will not be much effort. Okay, but efforts will be in the DFT part, right? DFT part, Z transform part, FFT is now removed actually. So Z transform, DFT, Laplace is also simple. Okay, Z be mostly simple, but sometimes they put up the good question from Z. Okay, sometimes they put up. So one more question, gate 21, that's 1 mark question only. Gate 21 का question भी complete कर लें. So I'll write, not here. Okay, so I'll write down, that also is not typed with me right now. Okay, so now the current year, gate 21 का भी एक level देख लो. This one is again conceptual, 1 mark है because it is not lengthy. If somebody knows, then he can easily crack it. Consider two 16 point sequences. Consider two 16 point sequences xn and hn. Okay, chalo. Now let their linear convolution, let their linear convolution be yn. So it is a question which is going to talk about linear convolution and circular convolution both. ठीक है, okay Gajendra, noted. I will try for that also. Okay, let Zn be the 16 point. Let Zn be the 16 point inverse DFT, IDFT of of the 16 point, जैसा लैंग्वेज है वैसा ही लिख देते हैं, of the 16 point DFTs of XN and HN. Okay. The question is the values of K for which Z of K will be equal to Y of K is slash R, option number A, K equal to 0, 1, 2, etc. 15. That means all values of K. So option number A should be wrong. Okay, option number A should be wrong. Okay, option number A should be wrong. Option number A says कि for all values of K, the linear convolution and circular convolution should be same. If you read the question carefully, you will find that ZK will be representing circular convolution. So that is not correct. Option number B, K equal to 0. Option number C says K equal to 15. Option number D says both K equal to 0 and 15. Come on, get hold of this. Hello Srijit. Yes, everybody. Yes. Yes, come on, tell me. Yes guys, tell me. Chalo, Arushi says 15. Let's try it up. Okay, so dekho, first of all let's read this language. Zn be the 16 point IDFT of the 16 of the product of, I think I have missed one word, of the product of 16 point DFTs of Xn and Hn. Sorry, of the product of. Okay, so what is Zn? Isko samajhna. What is Zn? What is Zn? It is the IDFT of the product of 16 point DFTs of Xn and Hn. Xn और Hn के DFTs को Xk और Hk बोल देते हैं. So there has to be a product of Xk, Hk, and Zn is the IDFT of them. Okay, so multiplication in the DFT, multiplication in frequency domain, the convolution in time. That means what should be Zn? What should be Zn? Xn. Convolution, but which convolution? Circular convolution. So indirectly they have given that Zn is the circular convolution and Yn is the linear convolution, clearly told. Yn be the linear convolution. So at which point the linear and circular convolution will be same? At which point the linear and circular convolution will be same? Okay, just note with me. Kiska convolution? Xn or Hn ka? So x0, x1, x2, etc. Pura solve nahi karna. I don't think that you have to solve this much. I'll just show you one glimpse and you will understand. Okay. Similarly, yahan pe rakha h0, h1, h2 up to h15. Multiply h0, x0, h0, x1 up to h0 with x15. Then what you will do? First, let's do the linear convolution part. So h1, x0, h1 with x0, h1 with x1 and etc, etc, h1 with x15. Okay, and yahan pe again I will place, sorry, h1 with, yahan pe aayega h1 with x14 and then h1 with the x15, 1 unit right shifted, and again that window will be placed here. Again that window will be placed here. Okay, now next, what is next? With h2, so h2 x0, h2 x1, यहाँ पे आ जाएगा h2 x14, finally h2 x15. So even when you do the circular convolution, you will shift this value here. Okay, now I am not going to write everything, otherwise it will become messy. Just try to understand orally. Okay, what will be the result? यहाँ पे अगर लिखेंगे h15 and x0, ये जो है ना पहला सैंपल यहाँ से स्टार्ट होगा. So when you do the linear convolution, okay, when you do the linear convolution, look at this last value. Okay, Look at this last value. Look at this last sample. Whether you do the linear convolution or even if you do the circular, in circular what you will do? You will shift these samples here, and as soon as you shift this sample here, the answer of linear convolution is only h naught x naught, but answer of circular convolution will be so many values. So they are not the same, but they will be same only at one value. They will be same only at one value. That is the last sample. That is the last sample. They will be same. Last means k equal to 15. Last means k equal to 15. So they will be same only for k equal to 15. I am not filling up the entire table. I hope verbally it is clear to everyone. Because in the circular convolution, all these values will be circularly folded. All these values will be circularly folded. यहाँ पे हम circular shift apply करेंगे, right? But even if you shift the last column, this is same for both. This is unaffected. This is same for linear as well as circular folding. Correct? This will remain same. क्योंकि यहाँ पे change shift करने का scope ही नहीं है ना. How many values will you shift here? 14 values will come up in this first volume. ठीक है, तो यहाँ values change होगी, but this column is common to both. This column is common to the circular convolution method and the linear convolution method. और इसीलिए मैंने आपको मेथड्स भी ऐसे बताएं so that you are able to connect both of them. Correct answer is option number C. Correct answer is the option number C. Now to be very true, if you know both the methods na, in the exam time, since it's a 1 mark question, exam time you don't have to even draw this table. I am just drawing for your explanation. थोड़ा थोड़ा मैंने draw किया so that you understand. Actually when I calculate, if you are practice with the DFT, you can understand it is only the last sample. Just in the mind you can calculate. That is why it's a 1 mark question. We can solve it up verbally and orally. Okay. Now tell me one more thing here, guys. I need one more opinion before I move forward. 2 questions actually I will have for you. Okay, 2 questions. Okay, time is nearly approaching 2, but कोई tension नहीं है. I have 2 questions for you. Okay, are you now comfortable and understanding DFT? थोड़ा practice आपको और करना पड़ेगा, but still we have taken problems. अभी कुछ और भी आगे लेना है मेरे को. But my first question is, are you now getting comfortable with the DFTs? Simple question to good questions. Are you understanding DFT? पहले मुझे ये confirm कर दो. Right? Either by your comments or either by your expressions. Even expressions will make me understand ki how your state of mind is right now. पहले इतना बोलो. Then I will have the question number 2 for you. Everybody, waiting for your comments so that I will bring up the question number 2 and then I will bring up the future proceedings. Comfortable है, easy है, थोड़ा practice और करना है. Practice everyone is needed for every topic, not only DFT. यार, no one is a magician on screen. I can just help you. थोड़ा practice तो आपको करना ही होगा. Come on, everybody. If you have doubt, say doubt. If you're not comfortable, say no. ठीक है, इसमें कोई it's not the point to hesitate. I'm just asked you a question. Answer can be yours. Question मेरा है, answer आपका होगा. So there, everybody. Some comment has to be there by everybody. Yes or no? Answer is your question मेरा, जवाब आपका. बोलिए. Yes. Okay. Now, my second question is, still some people are little lazy in commenting. थोड़ा lazy सा कुछ लोग हो रहे हैं, but no issues. Maybe you might be feeling hungry, so वैसे बैठे हैं. Now next question is, guys. Next question is कि if we are this much comfortable in DFT, by using the same knowledge, can we learn DFS? By using the same absolutely 100% same knowledge, can we learn DFS also? Discrete Fourier series. So do you want discrete Fourier series connection with DFT? बता दो मुझे. Do you want? Because in the gate we can expect the discrete Fourier series also, both EC and EE. Clearly the syllabus says Fourier series analysis of continuous and discrete time signal. Okay, so can we connect the DFS and DFT? 100% same, nothing extra. I say 0% extra. DFS, if you are having the smart approach, you don't have to study DFS. DFS पढ़ने का जरूरत ही नहीं है. You don't have to study the DFS separately. If you need it, comment. I'll tell you, it'll take maybe 2-5 minutes to give you that connection. Okay. So with this class, not only DFT, you can be assured that DFS is also done. What is that connection? Chalo. What is that connection? यहाँ ध्यान देना एक बार, यहाँ पे ध्यान देना. Yes. So what is the DFS basic formula? DFS, the discrete Fourier series. So I hope everyone knows the formula of DFS ना. ठीक है, formula तो एक लाइन में लिख देंगे. What is the formula for DFS? In the Fourier series, we always try to break a signal xn into the linear combination of complex exponentials, right? Summation, okay, summation ck e raised to the power jk omega naught n. That is what is the formula na. Xn is equal to summation of ck e raised to the power jk omega naught n for all the values of k. First of all, we write down for all the values of k, summation ck e power jk omega naught n, where ck is what? So how to complete this Fourier series? To complete the Fourier series, you need the Fourier series coefficients. Okay, what are the ck? They are known as the discrete Fourier series coefficients, right? What is the discrete Fourier series coefficient formula? What is the ck formula? ध्यान देना. What is the ck formula? Ck is given by 1 upon n. Okay, 1 upon n. What is n? N is the time period. एकदम rectified रखते हैं. So we have a periodic signal. You define the Fourier series for periodic signals only, na? You define the Fourier series for periodic signals. So let's take xn be a periodic signal. Let us say that xn be a periodic signal with period n, and fundamental frequency omega naught. What is omega naught? 2 pi by n. The omega naught that is coming is the fundamental frequency of the signal. So what is the ck? 1 upon n summation for one time period x of n e raised to the power minus jk omega naught n for one time period k equal to 0 to n minus 1. Sorry, n equal to 0 to n minus 1. Now what is this omega naught? Fundamental frequency of the signal, that is 2 pi by n. Fundamental frequency of the signal, that is 2 pi by n. So this is actually 1 upon n summation of x of n e raised to the power minus, I think board is also now tired, e raised to the power minus j k e raised to the power minus j k omega naught. So the board is now started irritating me. 2 pi by n into n. 2 pi by n into n. Now guys, all my dear students, what is this formula for? भाई ये किसका formula है? What is this formula? Summation xn e power minus j 2 pi by n into kn. Tell me, what is this formula? Isn't it the DFT formula repeated? This was the discrete frequency. See this discrete frequency e power minus j omega n. Summation xn e power minus j omega n. DFT formula na? Basically DFT formula with the frequency being the discrete frequency. This is known as what? This is known as the discrete frequency formula. This is nothing but the DFT formula na? This is nothing but the DFT formula. That means ck is just 1 by n x of k. Now if you are comfortable in the calculation of xk, I told you na, what is the ck? To complete the Fourier series of any signal, you need ck na? What is ck? 1 upon n xk, finish. So if you know the methods, the properties, the tricks to calculate xk, you can calculate ck. Just you have to multiply by 1 by n. So that is not any effort. Na? Everybody can multiply by 1 by n at the last. If you calculate xk, you can get the ck also. You can get the ck also. That's it. Finish. Ekdam simple question. Finish ho gaya. The question is finished. Acha. One more thing. We know that x of k plus n equal to xk. Every DFT is periodic na. Every DFT is always periodic with the period n. X of k plus n equal to xn. So ck plus n will also be ck. Fourier series coefficients are also periodic. Fourier series coefficients are also periodic. Fourier series coefficients are also periodic with the period n, right? Fourier series coefficients are also periodic with the period of the n. Chalo, now let me take you towards a journey. Here it is. So see, I have one gate question for you. Oh, Amit, we take only one series. That is DTFS and DFS. That is same. उसको same ही लेके चलेंगे. Okay, Amit. चलो. Consider a discrete time periodic signal xn equal to sine pi n by 5. Let AK or CK, it's the name depending on book to book. Let AK be the complex Fourier series coefficients of xn. Okay, the coefficients AK are non-zero when k equal to bm plus minus 1 where m is any integer. What is the value of b? See, बहुत ही simple सा question है ये. Okay, xn is equal to sine of pi n by 5. Xn is equal to sine of pi n by 5. Okay, now whenever you want to write down the Fourier series, of a trigonometric function, especially sinusoidal function, whenever you want to write down the Fourier series for a sinusoidal function, the simplest method is Euler's method, Euler's expansion. E power theta, sine theta is e raised to the power j theta minus e raised to the power minus j theta divided by 2j. Acha, whenever you write sine pi n by 5, I say that what is the value of omega naught pi by 5, sine omega naught n, and the period of the signal is 2 pi upon pi by 5, that will be 10. Okay. Now, if you eventually separate this out, you have 1 upon 2j e raised to the power j pi by 5. Dekho, e power j, how much pi by 5? 1 times pi by 5, j 1 into pi by 5, okay, into n, and then यहाँ पे लिखेंगे plus minus 1 by 2j e raised to the power j into minus 1 into pi by 5 into n, because in the Fourier series we want to write down the e power jk omega naught n, e raised to the power jk omega naught n. ये हो गया omega naught, and this is what is the value of k. This is the value of again omega naught, this is the value of k. That is what you want to write down in the Fourier series, na? That is what you want to write down in the Fourier series. Have a look at this. Summation of ck e power jk omega naught n. Okay, summation of ck e power jk omega naught n. So the coefficient multiplied is known as ck. So from here I am able to judge what is the Fourier series coefficient. C1 is 1 by 2j. ck, k ka value 1 hai, k is 1, and the Fourier series coefficient c minus 1 is 1 by 2j. Okay, but what is c minus 1? As per our properties discussed, okay, c minus 1 should be equal to c minus 1 plus 10, क्योंकि the signal is periodic with period 10, right? C minus 1 plus 10, and that is also C9, right? So I can say that there are only two Fourier series coefficients. C1 को भी एकदम simple करके लिख देते हैं. C1 को भी simple करके लिख सकते हैं. So where m is any integer, what should be the value of b? Tell me now. Answer, guys. What should be the value of b? The coefficients ak are non-zero when k is bm plus minus 1, where m is any integer. What should be the value of b? So dekho, I have the idea now. C1, what should be C1? C1 is C1 plus 10, that is C11. So what are the non-zero coefficients? Okay, what are the non-zero coefficients? Either C minus 1 and C1. अगर directly लेना है तो C minus 1 and C1 are non-zero, or C minus 1 is C9 and C1 is C11, or C9 and C11, or Fourier series coefficients are periodic, so they will keep on repeating, or it will be C19 and C21. So they are separated by a plus minus 1 distance about 10 or 20 or 0. So they can be represented as C of which one? 10m plus minus 1. 10m plus minus 1, where m is any integer, m को 0 लो तो c plus minus 1, m equal to 1 तो c 10 plus minus 1 मतलब c9 c11, m equal to 2 तो c19 c21. So what is the value of b? What is the value of b? b equal to 10. What is the value of b? b is equal to 10. Right, the value of b is 10. That is the answer. Simple question for 2 marks. Okay. Chalo, one more. So gate 15, 2 marks, again based on the discrete Fourier series, DFS. Let xn is equal to 1 plus cos pi n by 8 be a periodic signal with period 16. 2 pi upon pi by 8 is 16. Its DFS coefficients are defined by, we all know this definition. This is, they have given, बहुत अच्छे लोग हैं, उन्हें definition दे दिया, but I don't want, I already know what is this. I already know what is this AK or CK. So AK should be written as 1 upon n, the DFT. What is this? That is the DFT formula. That we anyways know. I don't want it. E power minus j 2 pi by 16. 2 pi by 16 is written as pi by 8. Simple किया है. What is the value of the coefficient A31? What is the value of the coefficient A31? So देखो, again, what is the type of the function, students? What is the type of the function? It is a sinusoidal, cos pi by 8n. Cos pi by 8n. Arey baba. Let me allow him some time. I think board is tired. We are not, but board is tired. Right? No issues. So 1 plus, whenever I told you sinusoidal, the best way of writing the Fourier series is Euler's method. So cos theta is e raised to the power j theta plus e raised to the power minus j theta divided by 2. Divided by only 2. Okay. So I can write this as 1 plus 1 by 2 e raised to the power j into 1 into pi by 8 n plus again 1 by 2 e raised to the power j into minus 1 into pi by 8 n. What is this? This is known as the value of omega naught. Omega naught is 2 pi by 16, na? Omega naught is 2 pi by 16, and that is why it is pi by 8. So what is this k? K is 1. What is this k? K is minus 1. So this calculation is giving you the value of C1, that is equal to 1 by 2. This is also giving you C minus 1 again, and that is also 1 by 2. These are the coefficients, and this is the DC component. DC component means I can say C naught. C naught is 1. DC component is 1. What is the value of the coefficient A31? Okay, what is the value of the coefficient A31? So A31 is A15 plus 16, and that should be A15, right? A15 can be further written as minus 1 plus 16. So A minus 1 plus 16 should be A minus 1 because of the periodicity. So answer should be A minus 1. What is the A minus 1? Yeah, C minus 1. One and the same thing I write by 1 by 2. 0.5 NAT type answer. 0.5 NAT type answer. These were on the trigonometric function. Now I can give you one, homework based on this. Okay. One question as homework based on this. मैं क्या बोलता हूँ? Write down. Let xn be a periodic signal. Randomly एक homework लिखते हैं. Let xn be a periodic signal with period 4, and what is the xn? I give you any random periodic signal, 2, minus 1, 3 and 6 suppose, right? Question will be very simple. Find the discrete Fourier series coefficients. Find the discrete Fourier series coefficients. Will you take time in solving it? Yeah, will it be easy? Yeah, chalo, I think it will be extremely easy. What homework? Finish karte hain. I know many of you will forget the homework otherwise. Isko complete hi kar dete. Find the discrete Fourier series coefficients. So what is the formula I am going to use, guys? What is the formula I am going to use for finding its discrete Fourier series coefficient? Tell me. What is the formula? So the discrete Fourier series coefficient Ck can be obtained as 1 by n xk directly, and use the results, whatever results you know for DFT. DFT is very simple for us. आप लोग बोल रहे थे ना DFT से comfortable हो गए, and this is indirect नहीं, this is very direct DFT question. We have taken direct and indirect tricky questions of DFT. ये तो बहुत simple है. So what is x0? What is x0? Summation of xn 2 minus 1 3 6 2 minus 1 3 and 6, तो हो गया 11 minus 1 10 हो रहा है. Okay, central ordinate x of 2 minus minus 1, alternate plus minus, plus 3 and minus 6. So this is again 2 plus 1, that is 3. 3 plus 3, 6 minus 6, 0. This is 0. Acha. Then what is the x1? What is the x1? Same, summation of xn. Twiddle factor is minus j, तो minus j power n for n equal to 0 से 3. तो एक एक करके वैल्यू ले लेंगे. The signal is 2 minus 1 3 and 6. तो 2 minus j की power 0. Then minus 1 j raised to the power 1, 3 j square, 6 j cube. So this is 2, this is minus j, 3 j square is minus 1, minus 3, minus 6 j cube is minus j. So कितना हो गया? 2 minus 3 minus 1 minus 7j, minus 1 minus of 7j. So what will be x3? It is x1 star, that is minus 1 plus 7j. All DFT properties you can use and make the question very, very simple. Make the question very, very simple. So my answer will be, Ck, as I told you, 1 by n of the DFT. So that will be 1 by 4 of the DFT obtained. The DFT is 10. Then minus 1 minus 7j, 0, minus 1 plus 7j. So the Fourier series coefficients are correspondingly 10 by 4, that is 2.5, minus 1 minus 7j by 10, इसको ऐसे ही लिखेंगे, then 0 and then minus 1 plus 7j divided by the value of 10. Finish. Right. Correct. Done. So we can easily find out the Ck by the motive of xk. By the motive of xk, provided that we will trust ourselves that we are quick and comfortable with the xk, with the DFT calculations. We should be quick and very much comfortable with the DFT calculations. Again guys, a reminder to you that tomorrow, okay, Saturday night, 12 AM, when Saturday ends, like tomorrow ends, when Sunday will become, midnight dose with me. All IIT Kharagpur general aptitude questions discussed with their solution, with their level, with their analysis, and what we can expect for the GATE 22 from the IIT Kharagpur. What we can expect for the GATE 22 from the IIT Kharagpur. Right, so non-stop marathon, midnight, right, jab tak chalega. Okay, how much time it takes? Okay, like today we took 3 hours, so it can take 2.5 hours, 3 hours, 4 hours, jitna hai, khatam karke hi soenge. Okay, one night for IIT KJP GA questions, right? Divide by 10 nahi, divide by 4. Divide by, misprint. Okay, Kishan, that's misprint. So that is divide by 4 and divide by 4 only. 10 by 4, 2.5. Correct? That's a misprint, okay? Right. So you can join me live tomorrow, kal track mate, Saturday night. Okay. So guys, PDF of today's session will, as always, my pattern, password protected. Okay. Password protected, my pattern. तो last होते होते कुछ लोग की देखो, many of you are live since 3 hours. Okay, many of you are live since 3 hours, so you should get that effort, na? You should get that effort. You should get that benefit. तो क्या benefit आपको देंगे हम? Let's make it small. DFT 1510. Simple password I am making today. DFT 15th of October. DFT 1510. That is the password. PDF will be in the Telegram group. PDF will be in my Telegram group, and that is going to be password protected. DFT 1510. So okay, so anybody with the password, okay, I only want the genuine users to open up that PDF. Okay, so if you want the link of the Telegram, here it is, the link of the Telegram. Okay, the PDF will be password protected. Don't share your PDFs. Yeah, we are planning digital revision. We will announce soon. Okay, so don't share the PDFs. It is your priorities, is your benefit. Okay, DFT 1510. Okay guys, that's it. Keep learning, keep enjoying, and also you can download the BYJU'S Exam Prep app, Google Play. Many classes available there also. Bye bye. Thank you. Stay safe and take care.